Hi everyone. So in this video we will start studying about Smith chart. Okay, a very important topic, and this year I am expecting that one question will come from Smith chart. Okay, so we will get into Smith chart. We will understand what do you mean by Smith chart, what does it represent. But before that, let's solve some mathematics. So a complex number is given that is x plus iota y. You need to show these number on xy plane. So that is very simple. In elementary 11th 12th classes we have already done it. So like there could be one way. What could be the way? That this is how I can show it. That this is my x, this is my y, x and this is my iota y, and this I can call as z plane, or in mathematics we call it Argand plane, right? Now I need to show this number, so what I can do is that I work 1 on x direction and under root 3 in y direction, so this will be the number. Or what could be the other way? The other way could be that you find the magnitude of this number. What will be the magnitude? Under root 1 square plus under root 3 square, that would be 2. And the angle, what will be the angle? Angle will be 60 degree. Directly you can see, and these kind of questions we have already solved. Angle will be 60 degree. Here what will be the magnitude? 2. But what will be the angle? Angle will be 120 degree, right? Because this will be in second quadrant. Since it is in second quadrant, so this will make 60 degree on this side. 180 minus 60, that would be 120. So these kind of things we have already seen. What will be the angle made here? That would be minus 120 degree. And what will be the angle made here? Amplitude are same only. What will be the angle made here? That would be minus 60 degree. So if I need to show these points, how will I show? That magnitude 2 and angle 60 degree. Magnitude 2 and angle 60 degree. So from here to magnitude line I will draw, and making an angle of 60 degree with x axis. So this will be the point, right? This will be the point 1 under root 3. In the same manner, magnitude 2 but making an angle of 120 degree. Magnitude 2 but making an angle of 120 degree. So that will be the other point. Then making an angle of minus 120, that means with x axis you will make an angle of 120 but in clockwise direction. So this will be the point, and then in clockwise direction you will make an angle of 60 degree. This will be the point. Okay, this angle is minus 60 and this angle is minus 120, and this angle is, forget about this 2, this angle is plus 120 degree. Is that clear? This is how we can show these points. So I am just calling this number is Z1, this is Z2, this is Z3, this is Z4. So simple mathematics thing we are doing, but this will be used in our Smith chart, and there you will be forgetting all these things. So that's why first I am dealing it, that you should know all these basic stuffs. Then you need to draw this circle. You need to draw this curve. Now this curve will represent a circle, or which category of the waveform it will represent, that you need to find. So z minus 2 minus 3j is equals to 1. So what is z? Z is x plus iota y minus 2 minus 3j, mod of that is equals to 1. So x minus 2 plus iota y minus 3, mod of that is equals to 1. So what we are getting? X minus 2 whole square plus y minus 3 whole square is equals to 1 whole square. So what is the x minus 2, not plus 2? So what is the equation we are getting? We are getting an equation of a circle. So why I am writing it again? So this is an equation of circle where 2, 3 is the center, and radius is 1, right? This is your x, this is your y. 1, 2, and here 1, 2, 3. 2, 3 is the center, and radius is 1. So from here one distance, and one distance. These one distance I need to pick, and this circle I will get. What will be this point? What do you think? This point will be x equals to 2 only, but y equals to 2. What will be this point? X equals to 2 only, but y equals to 4, right? What will be this point? From here I need to come 1. So y equals to 3 only, but x equals to 1. And what will be this point? Y equals to 3 only, but x equals to 3. So simple mathematics it is, you need to draw this circle, that's it. What about this? Z equals to x plus iota y again, you need to draw z equals to 2. So what is, mode of z equals to 2. What do you mean by mode of z? Mode of z is under root x square plus y square. That would be equals to 2 square. Okay. So what is this? This is also equation of circle whose radius is 2 and center is 0, 0. Center is 0, 0 and radius is 2. So what kind of circle we are getting? All these things I will relate with Smith chart. Okay, I am not wasting your time here. All these things will be related with the Smith chart. And radius here is 2. This is the radius which is 2. Right? So this is your x square plus y square is equals to 2 square. Okay. Let's solve one more problem. You need to draw circles but with radius 1 and center at 1, 1, radius 2, center at 1, 2, radius infinity and center at 1, infinity. So try doing it on your own. So first one, center is at 1, 1, from here 1 and from here 1. So this 1, 1, center is at 1, 1 and radius is also 1. So this distance would be 1, this distance 1, this distance 1, this distance 1. So simply it would be a circle. Simply this circle would be there, 1, 1, 1 and this is the center, that is 1, 1. This is the center 1, 1 with radius 1. So this is the first one. Then center is at 1, 2, x equals to 1 and y equals to 2. This will be 1, 2. Why is that so? Because this radius is 1. So this point will be 1, 2. So this is the center. This is the center and radius is 2. So from here 2 meter, from here 2 meter, from here also 2 meter and from here also 2 meter. So where you will be getting 2 meter, this will be 2 meter. Because in y direction you have worked 2 meter. So this will be 2 meter. Here I need to pick 2 meter. Here also I need to pick 2 meter. Here also I need to pick 2 meter. So how I will be getting it? What will be this point, by the way? 1, 0, right? This point will be 1, 0. All these things will be related. So don't think that your time is getting wasted. No, your time is not getting wasted. All these things will be related with Smith chart. That's why I am spending some time here. So this will be the other circle with radius 2 and center at 1, 2. I hope you got how the radius is 2. Because what is this point? This point is x equals to 1 and y equals to 2. What will be this point? Y equals to 2 only, but x equals to minus 1. Why is that so? Because you have worked for 2. What will be this point? Y equals to 2 only, but x equals to 3. What will be this point? This point will be x equals to 1 only. But what is y? Y equals to 4. Because you have worked 2. So in that manner. And what will be this point? 1, 0 only, because in y direction you have worked 2. So x is 1 only, but in y direction we have worked 2. So this is the other circle. This is simple mathematics. I am not explaining like right from the scratch, but these things you need to know. Now what about the last one? The center is at 1, 0 and radius, center is at 1, infinity and radius is infinity. So let's draw it on somewhere here. Okay. In the first one, where was the center? At 1, 1. Now let's just say this is the point of 1, infinity. Obviously this is not 1, infinity, but I am assuming that this is 1, infinity. Where will be 1, infinity on y-axis? It will be too far away. It will be too far away here, right? So let me take it a bit downward. So that 1, infinity will be too far away. Too far away, right? Are you agreeing to this point? Now, from this center, I need infinity distance here, 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 infinity distance here. Why is that so? Because my radius is infinity. So what do you think? How will the circle go? Infinite distance you need. And this point is also too much far away. This point is not here. The center is 1, 2. No, this is not 1, 2 center. The center is 1, infinity. So this point is also very far away. So how do you think this curve will look like? This curve will look like something like this, right? That from 1, infinity you will come infinity downward. That means on y direction you have covered infinity distance. If your center is 1, infinity, that means you in y direction you have covered infinity distance. Now in negative y direction you will come downward for infinity. Are you getting this point? What is the meaning of radius? Here 1, 2. Radius was 2. So you came down for 2 distance. Here your center was 1 comma 1, but the radius was 1, so you came down for 1 distance. Similarly, here your center is 1 comma infinity, but your radius is infinity, so you will come down for infinity distance. Are you getting this point? That means you will come to x-axis only. Here all the circles will coming to x-axis only. Do you agree to this point? Here radius was, here center was 1 comma 2 and the radius was 2, so it was coming to x-axis only. Again in this manner as well, here the center is 1 comma infinity, but the radius is infinity, so infinity distance you need to cover. That means again you will be coming on x-axis only. So the circle will be like this, and a very big circle will be there. So how it will look like? It will look like a line on x-axis. What I am saying is that the circle will look something like this. Like obviously the circle would be going like this, and this is like a curvature, and again coming here. Basically it will have this structure only, but it will be very big. It will be too big. Like this circle, then a bigger circle, then bigger circle. If it is too big, then it will feel like that this line is completely lying on x-axis. So this is your third circle. Third circle is simply a line. It will feel like a line. Actually, at infinity distance, it will become a curve. At infinity distance, this line will become a curve and it will make a circle. Are you getting this point? If you are not understanding, then you can mug it up. That center at 1 comma infinity and radius is infinity. Then this is how the circle will look like. This you can remember. Center is somewhere else. Center is somewhere else. 1 comma infinity. It will come downward for infinity. Here it will go for infinity. Here it will go for infinity. Here it will go for infinity. Upper side also it will go for infinity. Everywhere it will go for infinity. So this is how the circle will go. Are you getting this point? So on x-axis it will feel like that. This is a simple line. So line will be coming from here as well. Are you getting this point? Like this is how the circle will go, no? This is how the circle will go. So line will be coming from here as well. So a complete x-axis line will be there. So that will be the equation of circle. A very important point, it will be used in our analysis. Okay. So that's why I spent a lot of time here. There I am not going to spend this time. I will simply tell that how will the circle look like. So the circle will be simply a line like this. Are you getting this point? So this is how your circle will look like. Again we will see it. Okay. Do not worry about it. But this was a good concept. So all these questions we have seen. Now let's move to our Smith chart. But before that, we need to understand a term. This will be again and again used, which is normalized impedance. Okay. What do you mean by normalized impedance? So do you remember the formula of voltage reflection coefficient at load? Yes. ZL minus Z0 upon ZL plus Z0. Now what I am doing is that I am dividing by Z0 on numerator and denominator. So what I am going to get? ZL by Z0 minus 1 upon ZL by Z0 plus 1. So what is ZL by Z0? I am calling this as ZL dash. Okay. So ZL dash minus 1 upon ZL dash plus 1. I am calling ZL by Z0 as ZL dash. So my ZL dash is ZL by Z0, and this is known as normalized impedance. Okay. This is known as normalized impedance. Are you getting this point? Now this normalized impedance could be complex as well, because ZL can be complex, Z0 can be complex. So this normalized impedance ZL dash could be R plus JX, where R is the resistive part, and this is the reactive part. Or you can say R is the resistance and X is the reactance. Okay. R is the resistance, X is the reactance. Okay, a lot of dogs are barking, so I will pause the video and I will check if their sounds are coming or not. If their sound are coming, then it will be problematic for you. So I will have to pause the video as of now. Okay. Yeah, so let's begin again. Now there will be no sound. So what I was doing is that I was writing down my reflection coefficient at load. So that I wrote down as ZL by Z0 minus 1 upon ZL by Z0 plus 1, where I am calling ZL by Z0 as normalized load impedance, which is known as ZL dash. This ZL dash can be complex, because ZL can also be complex and Z0 can also be complex. So certainly this ZL dash can be complex. And how I can write it down? R plus JX, where R is the resistive part and X is the reactive part. X could be negative, positive, anything, and resistance will always be positive. So this resistance will always be positive, but this can be both positive, negative, because if capacitive load is there, that means this would be negative. If inductive load is there, that means that would be positive. Okay. Now how I can replace my gamma L? My gamma L can be replaced as gamma L is ZL dash minus 1 upon ZL dash plus 1. So what is my ZL dash? That is R plus Jx or iota x, whatever you can call it, divided by R plus Jx plus 1. Now this gamma L can also be complex, right? Because we have seen for complex load, we have seen for capacitive load, we have seen for inductive load, gamma L was complex. So gamma L can also be complex. So this gamma L can be written as U plus JV or iota V. What I am doing is that I am replacing gamma L as U plus JV, because that can also be complex, right? So where U is the real part of gamma L, why we are doing so, everything will come to you. Okay, just have the patience. And V is the imaginary part of gamma L. So from here what I can do is that U plus iota V or JV, whatever you can call it, is equals to R plus Jx minus 1 upon R plus Jx plus 1. Now I am having an equation you can say, or any expression you can say. So this expression is in U, V, R and X. Now I can manipulate these equations, then I can compare the real part and imaginary part. What I am gonna do, I am gonna manipulate these expressions, then I am gonna compare the real part and imaginary part, and from there I can get two equations. So those two equations are known as constant resistance circle and constant reactance circle. So first equation that I am getting is this: U minus R upon R plus 1 whole square plus V square is equals to R upon 1 upon R plus 1 whole square. So what is the equation? What this equation represent? This equation represent as circle. So this is the equation of circle. Never forget what is U and V. U and V are just the real and imaginary part of gamma L. So never ever forget what is your U and V. Okay. Now what I can do is that, now this will be an equation of circle, but for which plane? For UV plane, right? If I say that on my horizontal axis I am replacing U and on my vertical axis I am replacing JV. So now it becomes a equation of circle whose center is at R upon R plus 1 comma 0 and whose radius is 1 upon R plus 1. Do you agree to this point? For this particular plane, which plane is that? UV plane, or what I can say, gamma plane. What was your Z? Z was X plus iota Y. This was your complex number. So what you were doing? X here, iota Y here. So I could have called it XY plane or Z plane, or in mathematics we call it Argand plane. Similarly, this is your complex gamma plane, because gamma can be complex. So directly you can say either it is gamma plane or complex gamma plane. So what is this? This is your gamma plane. So what you need to do is that you need to map something on gamma plane. What you are going to do? You are going to map something on gamma plane. What you are going to map? What do you think? What we are going to map? We are going to map ZL dash. What we are going to map? We are going to map ZL dash on gamma plane. Because what is your ZL dash? ZL dash is R plus Gx. Now what you are finding? You are finding the equation between U, V and R and U, V and X. Are you getting this point? So what you are going to do? You are going to map R on this plane and then you are going to map X on this plane. If I have mapped R and X, that means I have mapped my ZL dash. Slowly things are building up, no? Okay, slowly you are understanding the things. Certainly it will come to you. We will discuss it in a very in-depth manner. We are going to discuss a lot of things. So what we are doing, why I have made this plane? Are you getting this point? Because this equation I am getting, and now I need to make this equation as a equation of circle. When this will be a equation of circle, if I am having a plane like this. So for a plane like this, this is the center, which is R upon R plus 1 comma 0, and this is the radius. And for this one, what is the center? Center would be 1 upon 1 comma 1 upon x, and what will be the radius? Radius will be 1 by x only. Okay. So now what I am gonna do? I am gonna map this R on this plane, and I am gonna map this x on this plane. So this is my task. This is what I am gonna do. Okay. So I'm gonna map r and x on this plane. So with respect to different values of r, I will be getting different equations of circle, and that I'm gonna map. Okay, so have the patience and just see it thoroughly and have the pen and paper with you. Otherwise, you are not going to understand Smith chart. Okay, so yeah. So this was the equation. Center was at r upon r plus 1 comma 0 and radius was 1 upon r plus 1. This we have already seen, right? So now let's just say if value of r is 0, what is your r? R is coming from ZL dash, where ZL dash is your normalized load impedance. So if the resistive part of your normalized load impedance is 0, then what will be the equation of circle? Center will be at 0 comma 0 and radius will be 1. Equation of circle you can avoid or you can write down as well. U square plus V square is equals to 1 square. I don't know why I wrote this column. This is of no use, right? Equation of circle is of no use. Now the resistive part could be 0.5 as well. The resistive part of your normalized load impedance could be 0.5 as well. So if that is 0.5, that means what will be the radius? Radius will be 0.5 divided by 1.5, that would be 1 by 3 comma 0. Sorry, this is the center, not radius. And what will be the radius? Radius will be 2 by 3. Equation you can write down on your own. If resistive part is 1, then your center would be 1 by 2 comma 0 and your radius will be 1 by 2. If resistive part is 1.5, so 1.5 divided by 2.5, so that would be 3 by 5, right? So center could be 3 by 5 comma 0 and what could be the radius? That would be 1 upon 2.5, so 10 by 25, so 2 by 5. So radius would be 2 by 5. Okay, and if the resistive part is infinity, that means open circuit load, right? If resistive part is infinity, then if that is infinity, so what will happen? Center will be 1 by 1 comma 0. Why 1 comma 0? Because r upon r plus 1. This is also very large, this is also very large. So this 1 can be ignored. So r by r will be 1 only. So center will be 1 comma 0 and what will be the radius? 1 by infinity, that will be 0 only. So radius will be 0. Are you getting this point? So what will be the equation here? Equation will be u minus 1 whole square plus v square is equals to 0 square. So you need to make a circle which is having center at 1 comma 0 and radius is 0. Radius is 0 means this point only, no? A point is also a circle which is having radius equals to 0. Are you getting this point? Point is also a circle which is having radius equals to 0. So now we will make all these circles. Okay, we are going to make all these circles. So our first circle is center at 0 comma 0 and radius is 1. Center at 0 comma 0 and radius is 1. So this is how I can make it. Center at 0 comma 0. Let's not make 0 comma 0 and radius is 1. This radius is 1 that I am telling. So this is coming for resistive part equals to 0. This r is not radius, this is the resistive part. So this circle is coming for resistive part equals to 0. Resistive part equals to 0. If now resistive part is 0.5, if resistive part is 0.5, so center will be 1 by 3 comma 0. Let's just say this is 1 by 3 comma 0. Center will be 1 by 3 comma 0. Let's just say this is 1 by 3 comma 0. I will erase it. Now the radius is 2 by 3. So from 1 by 3 you need a distance 2 by 3 where you will reach at 1 comma 0 only. So this will be the center and then you will make a circle. This will be the center and you will make a circle which is having 2 by 3 this side, 2 by 3 this side, 2 by 3 this side and 2 by 3 this side, right? So this is this kind of circle you are going to make. Are you getting this point? Initially for the first one, for r equals to 0, this was your center 0 comma 0 and radius was 1. So 1 here, 1 here, 1 here, 1 here. For the second one, what was your center? Center was 1 by 3 comma 0. 1 by 3 comma 0. So and radius is 2 by 3. Radius is 2 by 3. So 2 by 3 here, 2 by 3 here, 2 by 3 here and 2 by 3 here. So this circle we are getting. Now for the next one, what is the scene? For the next one, the center is at 1 by 2 comma 0. Center is at 1 by 2 comma 0. So this point is 1 comma 0. Are you getting to know this point? This point is 1 comma 0, right? Now this is the center 1 by 2 comma 0. Now the center is at 1 by 2 comma 0 and radius is 1 by 2. So 1 by 2 here, 1 by 2 here, 1 by 2 here and 1 by 2 here downward. 1 by 2 upper side, 1 by 2 downward side, 1 by 2 here and 1 by 2 here. So what kind of circle you will be getting? This kind of circle you will be getting. Are you able to understand? Say yes or no. So this was the circle for r equals to 0.5. This is the circle for r equals to 1. Now you need to make circle for r equals to 1.5. So 1.5 center is that 3 by 5 comma 0. Let's just say this is your 3 by 5 comma 0. Now radius is 2 by 5. What is the radius? Radius is 2 by 5. So 2 by 5 distance here, 2 by 5 distance here, 2 by 5 distance here, 2 by 5 distance here. So 3 by 5 plus 2 by 5. What you are going to get? 5 by 5, that is 1 comma 0 only. So again you are going to pass through 1 comma 0 and circle will be made something like this. So this was your r equals to 2, right? This was your r equals to 2. That it's not 2, sorry, r equals to 1.5. This was your r equals to 1.5. Now from 0 to directly I took 0.5. In between there would have been 0.33 as well. No? Here 0 to 0.5 I directly took. So in between there would have been 0.33. So which kind of circle 0.33 would make? What do you think? Say yes or no. This kind of circle. This could have been the register circle for 0.33. In between 0.5 to 1, there could be 0.75 as well. So what kind of circle 0.75 would make? Somewhat like this. But all the circles will certainly pass from 1 comma 0. There is no doubt about that. This could be 0.75. Now this is your 1.5. More values could be there. This could be your 2.5. R equals to 2.5. This could be r equals to 2.5. In the same manner, circles are getting lower. When r goes infinity, the center is at 1 comma 0. Center is at 1 comma 0 and radius is 0 only. That means this is the point. So this point is r equals to infinity. Did you understand these equations of circle? Very easy it is. Simple mathematics. So these are the equations of circle. So what we have done here, we have mapped the value of r, mapped the values of resistive part of ZL dash. What is ZL dash? Normalized load impedance. We have mapped the values of resistive part of ZL on gamma L plane. So this was your gamma L plane. On the gamma L plane, you have mapped the resistive part of your normalized load impedance. This is what you have done. A very important language. That on complex gamma plane, we are mapping the value of R. Now we will map the value of X as well. And then we will combine both of them. This is what we are doing. And when we combine both of them, we will get our Smith chart. So this is our Smith chart. Are you getting this point? So these are the values. So another point to note is that r equals to 0 makes the biggest circle. R equals to 0 makes the biggest circle. And although all these points will be written in the last of the particular chapter as well, but here also we are writing. And as r increases, the radius decreases. That means size of circle decreases, right? What else you can write? All the circle passes through, all the circles passes through 1 comma 0. This also can be written, right? All the circles are passing through 1 comma 0. This can also be written. So these are the conclusion. Now let's do the same thing for this constant reactance circle. Okay, constant. And why they are known as constant resistance circle? Because on this particular circle, on this complete circle, the value of resistance is 0. On this complete circle, the value of resistance is 0.5. On this complete circle, the value of resistance is 1.5. So that's why they are known as constant resistance circle. Okay. Now we are going to draw constant reactance circle. So similar manner we are going to put the values. If x is equals to 0, so center will be at 1 comma infinity and radius will be infinity. Drop the equation of curve. Okay, here center will be at 1 comma 1 and radius will be 1. Here center will be at 1 comma minus 1 and radius cannot be minus 1, right? Radius has to be the magnitude, right? Radius is a length, so length cannot be negative, so radius will be 1 only. Are you getting this point? Center will be at 1 comma minus 1 but radius will be a length, right? So this will be 1 only. Here center will be at 1 comma 1 by 2 and radius will be 1 by 2. Here center will be at 1 comma minus 1 by 2 but radius will be 1 by 2. Here the center will be at 1 comma 2 but the radius will be 2. Here center will be at 1 comma minus 2 and radius will be 2. And here center will be at 0. I have already taken. Again we are writing down nothing else. So have you seen this particular curve? Yes, we have seen. Let's draw it now. So what we are going to do, first we are going to make for x equals to 0. So center at 1 comma infinity and radius infinity. So what kind of curve you were getting, if you remember? It was completely on your x-axis, right? Let's take a different color. It was completely on x-axis. This is what we were getting. So from here we are not going to make anything conclusive, but let's make other one. So center at 1 comma 1 and radius is 1. Let's just say this is 1, or let's call this as 1, this as 1 and this as 1. So center at 1 comma 1 and radius is also 1. That means 1 here, 1 here, 1 here and 1 here. So how will the circle go? So this is how the circle will go, right? Because from 1 comma 1 if you are moving 1 here, that means y axis is 1 only but x is 0, right? So these we have already seen. That's why I spent some time on the basics of circles. So now you should be comfortable by making all these things. So this is coming for, this was coming for x equals to 0, right? Here I should have put x equals to infinity, actually not 0. I should have put x equals to infinity. So for x equals to infinity, 1 comma 0 and radius is 0. Okay. So this is coming for, initially this came for x equals to 0, this came for x equals to 1. Now we are making for x equals to minus 1. So similarly, did to same thing, but it will be made downward. Why is that so? Yeah, so what I was saying, 1 comma minus 1 and radius is 1. So here the center is 1 comma minus 1. 1 comma minus 1 and radius is 1. What do you think? What is this point? This point where both of the curves are touching. This point is x equals to 1 and y equals to 0. Right? This point is x equals to 1 and y equals to 0. Now let's make other ones. Center is at 1 comma 1 by 2 and radius is 1 by 2. So this was your 1 comma 1, right? This was your 1 comma 1. Where will be your 1 comma 1 by 2? Somewhere here. 1 comma 1 by 2 would be somewhere here, right? And here you need to go 1 by 2, 1 by 2, 1 by 2 and 1 by 2, right? So how will you make the circle? This will be made somewhat like this. Okay, and similarly downward this will be made somewhat like this. So this is coming for x equals to 2, this came for x equals to minus 1, this is coming for x equals to minus 2. Okay, now what about x equals to 0.5? Center is at 1 comma 2. So x equals to 1, this was your 1 comma 1. So where will be 1 comma 2? 1 comma 2 will be here. This is the center. 1 comma 2 will be somewhere here. This is the center and radius is 2 only. So 2 here, 2 here, 2 here and 2 here. So how will the circle look like? So circle will look something like this. So we are not able to show it completely, but circle is going upward, that I get to know, right? So this we are getting for x equals to 0.5, right? And similarly downward as well for x equals to minus 0.5. X equals to, this was your x equals to minus 1, x equals to minus 1, Now this we are getting for x equals to minus 0.5, x equals to minus 0.5. Now what do you think if x is equals to minus 0.33, or let's go here, if x was 2, then this was the circle. If x was 1, then this was the circle. If x was 0.5, then this is the circle. If x is reducing more, let's just say if x is 0.33, then what would be the circle? Then circle would be somewhat like this. Circle would be somewhat like this, right? This circle is for x equals to let's just say 0.2. And what about x equals to minus 2? So that circle will be somewhat like this. This circle is for x equals to minus 0.2. And just as the size of circle is getting bigger, when x is equals to 0, then it feels like it is completely horizontal. Later on at infinity it will become curvy, and then it will be closing like this. All the curves are passing from a certain point, that is 1, 0. Are you able to understand this thing? So this was your x equals to, and now what about x equals to 3? So x equals to 3 will be somewhat like this, right? X equals to 3 will be somewhat like this. What about x equals to minus 3? X equals to minus 3 will be somewhat like this. X equals to minus 3 will be somewhat like this. This is x equals to 3. So what it feels like? It feels like that from 1, 0, the circles are being originated. From 1, 0, circles are being originated in upward direction, also in downward direction, for the decreasing value of x. That means at 1, 0, if your x was infinity, then your center is at 1, 0 and radius is 0. That means this is the circle. Center is at 1, 0 and radius is 0. So this is for x equals to infinity. So at x equals to infinity, only one point is generated. Then if value goes lower, then some bigger circle, then some bigger circle. If x is equals to 3, then this circle. If x is equals to 2, then this circle. If x equals to 1, then this circle. X equals to 0.5, more bigger. 0.2, more bigger. 0, more bigger. Similarly downward as well. Minus 3, minus 2, minus 1, minus 0.5, x equals to minus 2. So this is the circle. So what we have done? We have done the mapping of reactive part of ZL dash on complex gamma plane. What we have done? We have done the mapping of complex part of, we have done the mapping of reactive part of normalized load impedance on complex gamma plane, right? So this is what we have done. Mapping of reactive part of ZL dash on gamma plane, or you can say complex gamma plane. What you can say, other thing what you can say, all the circle passes through 1, 0. All the circles passes through 1, 0. What else you can say? What else we can say is that, yeah, as x increases, as mode of x, I can say, as mode of x increases, or I can say as mode of x decreases, the radius increases. The radius increases. Now, what is the common things you see in both of them? Here also, all the circles were originated from 1, 0 only. If you see this diagram, what do you feel? That from 1, 0, circles are being originated. From 1, 0, circles are being originated in the horizontal direction. 1, 0, circles are being originated in the horizontal direction, right? And for that decreasing value of r, if r is infinity, then point. If r is 2.5, then this much circle. If r is 1.5, then this much circle. If r is 1, then this circle. 0.75, 0.5, 0.33 and 0. So for 0, this is the biggest circle. But here, from 1, 0, the circles are being originated in the upward direction and in the downward direction. In the upward direction, in the downward direction, for the decreasing value of x. For x equals to infinity, there is a point. For x equals to 3, this much circle. X equals to 2, this much circle. For x equals to 1, this much circle. For x equals to 0.5, this much circle. For x equals to 0.2, this much circle. For x equals to 0, so big circle that it is lying on simple x axis only, or you can say simple u axis only. Are you getting this point? And what is u and iv, or you can say jv? What is your u and jv? U is the real part of your gamma L and V is the imaginary part of your gamma L, where gamma L is equals to U plus GV. Is that clear to you? So we have done the mapping of resistive part and reactive part of ZL dash on complex gamma plane. So now we will make them, both of them, on one plane only. So first using yellow color, I am making my constant resistance circles. Oh, this is not yellow color, this is some different color. So these were my constant resistance circles. These were my constant resistance circles. So the circle that I made previously, that was also fine. Like there would be infinite circles. Are you getting this point? Like there will be infinite values of R, no? Like 0, 0 0.01, 0 0.02, 0 0.03. So there will be infinite circles like this. So that was also fine, but I don't want to make too many of circle. If I make too many of circle, then diagram will be unclear. तबीयत ठीक हो जाए यार पहले. But there will be no problem in the explanation. Like even if the health is good or not, but certainly explanation will be up to the mark. No need to worry about that. Okay, so these are the constant resistance circle I am making. This was your R equals to 0. This could be anything. This was your R equals to 1. Okay, these are two are very important. R equals to 0 and R equals to 1. Now what I'm gonna make? Now I'm gonna make with blue color of pen, and all these are passing from 1, 0. Now from 1, 0, more circles will be originated that will be going in upward direction from 1, 0 only. So this is how first one. Then in the same manner more will be originated. It will keep on originating. ये तो गड़बड़ हो गई थोड़ी सी, बन ही नहीं रहा है. Okay, fine. Okay, more will be originated like this, which are pretty bigger, which we cannot make. Same goes downward. Okay, let's make one more here. Yeah, let's make this one. Then there is a smaller one. And the one which is passing through this axis. Okay, so now let's rename them. So this circle was your R equals to 0. This circle was your R equals to 1, and here this point was your R equals to infinity, right? Okay, here the circle which is passing through this IV curve, this was your x equals to 1, right? This circle was your x equals to 1. Are you getting this point? This circle was your x equals to 1. So this circle is my x equals to 1. This circle is my x equals to 1. And here what was the value of x? There was one more line. This was your x equals to 0. This line was your x equals to 0. And here the dot was x equals to infinity. The dot was x equals to infinity. Are you getting this point? This was your x equals to 1. This was your x equals to minus 1. So whatever that I have shown on this diagram, those are very important. That this is my r equals to 0 circle. From this imaginary axis, r equals to 1 circle will pass, and certainly it will pass from 1, 0. Then x equals to 1 circle. X equals to 1 circle. This is your r equals to infinity, x equals to infinity. This is your x equals to 0, and this is your x equals to minus 1. And now certainly this will be x equals to 2 or 0.5. This will be x equals to 2. Why is that so? Because as the x value increases, the radius decreases. This will be some x equals to 5, let's just say. And what about this? This will be some x equals to 0.5. This could be some x equals to minus 0.5. What about this? This is r equals to 0. This is r equals to 1. So this could be some r equals to 0.5 in this manner. Now, whenever we draw Smith chart, we do not draw it like this. What we do is that we make a unit radius circle. Okay, we make a unit radius circle. In that circle only, we make all the resistance circle and all the reactance circle. What I mean to say is that this is how we make our Smith chart. In this curve is half. Actually, the complete curve will be something like this. What is this? This is your x equals to 1. So x equals to 1 completely will go like this only. X equals to 1 will completely go like this only. But we show it in the unity circle only. I will tell you the reason behind it, why we show it in unity circle. This is your x equals to minus 1. This will go completely, x equals to minus 1 will go completely like this. But we will show it till unity circle only. What is this? This is r equals to 0. This is your constant resistance circle, r equals to 0. In this diagram, if it is not clear, then here you can see r equals to 0. Whose center is at 0, 0. Whose center is at 0, 0 and radius is 1. What is this? This is r equals to 1. This is r equals to 0. This is r equals to 1. This is x equals to 1. This is x equals to minus 1. What about this? What is this? X equals to 0, the biggest circle. And what about this point? This point is your x equals to infinity and r equals to infinity. So these points you need to keep in mind. And why do we make it unity circle only? What is the reason behind that? So in unity circle, why I am showing it? Why I am not showing like this? Why I am not showing like this? What is the reason behind that? So the simple reason is, what is your plane? Your plane is u plus iota, u and iota v. And from where u and iota v are coming? From here u and iota v are coming. If I say mode of gamma L, what will be the mode of gamma L? Under root v square plus u square. What could be the maximum value of mode of gamma L? 1. Right? If I say this is my z, z plus z is equals to x plus iota y. So this is your x, this is your iota y. And here I make any line. The length of this line will be represented by mode of z, which is equals to x square plus y square. Right? Similarly, here I am making u and iota v. If I make any line, the length of this line will be represented by mode of gamma, and that will be u square plus v square, mode of gamma L. The length of this line will be represented by mode of gamma L, that is under root u square plus v square. And what could be the maximum value of this? That is 1. So any line if I am making here, that cannot go far from 1. So why should I make these parts? Are you getting this point? Which plane is that? Complex gamma plane. And the value of gamma L cannot be greater than 1. Right? The value of gamma L can never be greater than 1. So if it can never be greater than 1, that means any vector on this particular plane can never go above 1. It will remain in the radius 1 only. So why should I make anything which is apart from 1, like which is made here? Why should I make that? Are you getting this point? So that's why we always show it in unity circle. No one will ask you this, but still, if you know it, then it is good for you. Okay. So these are the points. This is r equals to 0, x equals to 0, x equals to 1, r equals to 1, x equals to minus 1. This curve is x equals to minus 1. This is 1, 0, from where all the circles are originated. Okay. And this point is your x equals to infinity and r equals to infinity. So till now, whatever that we have studied, let's revise it again. So from here we will revise, the rest of the part was mathematics only. So from here we will revise gamma L, load, reflection coefficient at load, voltage reflection coefficient at load. So that was given as ZL by Z0 minus 1 upon ZL by Z0 plus 1. So that I replaced with ZL dash. That was normalized load impedance, where resistive part is R, reactive part is X. Then I replaced it something like this, U plus JV I replaced. Then U plus JV and R, JX and U, V, R and X is having some relation. From there we get some relation, we get the equations of curve. So now what we are going to do, we are going to map our resistive part and the reactive part on the complex gamma plane, which is your UV plane. Okay, so first we mapped our resistive part. So here we go to know that our center is at R upon R plus 1. comma 0 and radius is 1 upon r plus 1. So we got to know that from 1 comma 0 circles are being originated in the horizontal direction, and it feels like that when r value is, if they are being originated, that means r value is being getting low. So for r equals to 2.5, this is the size, then r equals to 1, then r equals to 0. Okay, so this is the biggest circle, and here the biggest circle is at x equals to 0. Here the biggest circle is at x equals to 0, which is having infinity radius. So from 1 comma 0 circles are being originated. As the value of x increases, the radius decreases. So initially x equals to 3, x equals to 2, x equals to 1, x equals to 0.5, x equals to 0.2. Which was the most important points? The most important points were x equals to 1 circle, x equals to minus 1 circle. This is a complete circle only, but we are not going to show it because mode of gamma L can never be greater than 1. And this is also a complete circle only, but we are not going to show it completely. This is your r equals to 1, this is your r equals to 0, and this is your x equals to 0 circle only. This is also circle, but it will feel like that it is a simple line, because this is a circle having infinite radius, and this point is x equals to infinity and r equals to infinity. All these circles are passing through one common point, that is 1 comma 0. Now certainly we are going to discuss more things about it, but let me take a break. It's been roughly around 50 minutes, so I will take a break, drink some water. You can also do the same. You can revise whatever that we have studied. These 12 slides you can revise, then come back and we will discuss the further things about Smith chart. Okay. Okay, so let's resume now. Okay, so what we are going to find now? Now using the Smith chart, we are going to find certain things. We are going to find, first we are going to find gamma L on Smith chart. That how to find the reflection coefficient at load using the Smith chart. So first we will find it using our formula only. What was our formula? ZL minus Z0 upon ZL plus Z0. So 50J minus 50 upon 50J plus 50. Here I can see that my magnitude will be coming out to be 1 only, and the angle will be coming out to be, angle will be J minus 1, that will give you minus 1 J, 135 degree angle, and J plus 1 will give you 45 degree angle. So angle is coming out to be 90 degree. So this calculation we have already done actually, right? So gamma L I am getting is 1 and angle is 90 degree, or I can write it down as 1 e to the power j 90 degree, or I can write down my gamma L as simply j. So my gamma L is j, but we will find it using our Smith chart. This is our gamma L. Okay. Now if we are going to make Smith chart, that means I need to find normalized load impedance. What that would be? 50J divided by 50. That would be J only. Now if I make the Smith chart, what Smith chart tells? That on complex gamma plane you have mapped the value of R and X. How you have mapped R? So for R we know two circles. Majorly we remember two circles. What all are those circles? This is R equals to 0. Then there is R equals to 1. This is your R equals to 0 circle. This is your R equals to 1 circle. Okay. Then for X, what do we remember, and what is this? This point is R equals to infinity, and certainly this point is X equals to infinity as well. Okay, well and good. Now for talking about X, so for X, this is your X equals to 1 circle, this is your X equals to minus 1 circle. So what is this? This is your X equals to 1 circle, and this is your X equals to minus 1 circle. This is what we make, right? And X equals to 0 circle is also there. X equals to 0 circle is also there. This is your X equals to 0, right? Now if I get my ZL dash equals to J, which is equals to R plus JX, that means here R value is 0 and X value is 1. So now where R value equals to 0 is on this curve, and where X equals to 1, this is X equals to 1. Where both of them are cutting? They are cutting on this particular point. R equals to 0 and X equals to 1. They are cutting on this particular point. So this point represents your ZL dash. R equals to 0 and X equals to 1. What do you think what this point will represent? This point will also represent some ZL dash, but this point will be, because what is this circle? This circle is R equals to 1. What is this circle? This circle is R equals to 1. This circle is R equals to 1. So this point P, at point P, what is the value of ZL dash? Here R equals to 1 and X equals to 1 circles are cutting. That means ZL dash is 1 plus J. Point P. At point Q, what will be the value of ZL dash at point Q? That would be -1 and R equals to 1 circle. This is your R equals to 1 circle and X is equals to -1. So at ZL dash, the value of normalized load impedance at point Q is 1 minus J. Similarly, here R equals to 0 and X equals to 1. So here your ZL dash is there. So this is your actual ZL dash. Now you will pick this point and you will join this point to the origin. Okay. What you are going to do is that you are going to join this point to the origin. Now you will measure the angle with X axis. What is that? 90 degree. So this 90 degree is your gamma L. And this length, what is this? This length is 1. So this is your mode of gamma L. So from here gamma L you are getting is, that is J. Are you able to understand this point? First you will locate your ZL dash. Once I have located the ZL dash, this is not my ZL dash, this is my ZL dash. Once I have located the ZL dash, I will join this point to the origin. Now this length will represent mode of gamma L. I will join this point to the origin. This length will represent mode of gamma L, and this length is making an angle of 90 degree with X axis. That is my angle of gamma L. Are you getting this point? So this is how we do it. Okay, let's solve more problems. Normalized load impedance is given as 1 plus J. So what do you think? How will you show gamma L on Smith chart? So here my R value is 1 and X value is 1. So only R equals to 1 circle I am going to make, and R and X equals to 1 circle I am going to make. Only these two circles I am going to make. So this is my U, this is my JV. So this is my complex gamma plane. So R equals to 1 circle. This is my R equals to 1 circle. This is my R equals to 1 circle. Certainly this circle will pass from 1, 0, there is no doubt. Now from 1, 0 only another circle is originated, which is your X equals to 1 circle. Completely I am not going to make. Why completely I am not going to make? Because that is of no use. So this is my X equals to 1 circle, where both are cutting at this point. So this is my ZL dash. Now this point I am going to join to the origin. Now whatever the angle I get here, that angle I don't know. This angle I don't know. But this length, what this length will represent? Let's just say this point is P. So this OP length will represent mode of gamma L, and this theta will represent angle of gamma L. Now in the examination they make this particular diagram and they ask you the value of theta. Will you be able to tell me the value of theta? If they have made this diagram, you will get to know that your ZL dash is 1 plus G. Now can I find my gamma L? I know that this theta is the angle of gamma L. So can I find the gamma L? Yes, I remember the formula. What is that? ZL dash minus 1 upon ZL dash plus 1. So 1 plus J minus 1 upon 1 plus J plus 1. So what I am getting? J upon 2 plus J. This is your gamma L. So mode of gamma L, that is equals to OP. What that would be equals to 1 by under root 5. So if they are asking the length OP, that would be 1 by under root 5. If this length was 1 centimeter, let's just say if this length was 1 centimeter, then this length would be 1 by under root 5. And if they are asking the angle, which is equals to theta only, so that would be equals to 90 minus tan inverse 1 by 2. Are you able to understand what we are doing? Okay, this angle you can calculate whatever that you get. So on the Smith chart, if you are able to locate ZL dash, just use that point and join it to the origin. That length will be your mode of gamma L, and the angle that is made with X axis, that is your angle of gamma L. Okay, well and good. Now let's solve some problem based on this concept only. On the given Smith chart, distance D is your under root 5 centimeter. What is distance D? OA. This OA distance is under root 5 centimeter. You need to find the distance X and Y. What is X and Y? X is OB and Y is OC. Now they might not mention this circle. you should know which circle is that. Which circle is this? This is your x equals to 1 circle. They will mention this circle r equals to 0 circle. Okay. Which circle is this? This is your x equals to -1 circle. Right. Which circle is this? R equals to 1 circle. Now this point, what this point will represent? The ZL dash at point A, what that would be? At point A, which two circles are meeting? X equals to 1 and R equals to 1. That means ZL dash at point A is 1 plus J. Okay. So now this OA, what will be the length OA? OA will be mode of gamma L. But for which load? ZL dash at point A load. Basically, this OA will represent mode of gamma L. But for which load? 1 plus J load. So now I need to find mode of gamma L. That will be 1 plus J minus 1 upon 1 plus J plus 1. Which formula I am applying? I am applying this formula. ZL dash at point A minus 1 upon ZL dash at point A plus 1. So at point A, what is my normalized load impedance? That is 1 plus J minus 1 upon 1 plus J plus 1. So I am getting J upon 2 plus J. So that mode, if I am calculating, this is the complete gamma L I am calculating. If I am calculating only the mode of gamma L, so that is equals to your mode of gamma L is equals to OA, that is equals to D, that is equals to under root 5 centimeter, and that is equals to 1 by under root 5 unit, you can say 1 by under root 5 unit. So if your mode of gamma L, if your reflection coefficient is 1 by under root 5 unit, then the distance is under root 5 centimeter on Smith chart. So this you need to remember, okay, as of now. Now let's see what they are asking. Now they are asking me OB distance. What they are asking? OB distance they are asking. So this is my distance x. This is what they are asking. Now at point B, you let me know one thing. At point B, your R will be equals to 0. What will be your x? X could be anything. I don't know what will be the value of x. Basically, this is your x equals to 1. So this could be your x equals to 0.5. Really sorry. This is your x equals to 1 circle. So x equals to, this could be your x equals to 0.5 circle. It could be anything, right? X equals to 0.5 circle or x equals to 0.3 circle. It could be anything. Because if x value decreases, then circle increases. So it is having some value x1. I am not sure. At point B, which two curves will cut? This is one of the curve, which is r equals to 0. Then another curve would be there, which would be coming from here, right? These two curves will cut at point B. But this curve they did not make. By default, you should know, no, there will be another curve. So this curve I will make with a different color. That means I am making it with some, I am making this curve with some white pen. Okay, some white color. So what did you get to know that is that at point B, this is your x equals to 1, this could be some x equals to x1. I am not sure what is the value of x. So at point B, r equals to 0 will be there and x equals to x1 would be there. So what is the normalized impedance at point B? R is equals to 0, J equals to some x1. Is that clear to you? J equals to some x1. Okay. So if I find the load gamma L, what will be the OB distance? OB distance will be mode of gamma L. Here OB distance. What do? Wherever both of the curves cut, we take this point and join it to the origin. And whatever the distance this is there, whatever the length that is there, that is represented by mode of gamma L. So now your OB is mode of gamma L, but with respect to ZL dash B. So this we are calculating. So what is your mode of gamma L now? ZL dash B minus 1 upon ZL dash B plus 1. Okay, so this is Jx1 minus 1 upon Jx1 plus 1. Now I am not sure what will be the angle, but one thing I am pretty sure, what will be the magnitude of mode of gamma L here? Magnitude will be 1 only. What will be the magnitude? 1 unit. So here mode of gamma L is 1 unit, and that is pretty obvious. Why is that so? Because this is the maximum circle you can make on your complex gamma plane. This is the biggest circle which you can make on your complex gamma plane, because maximum value of your gamma, mode of gamma, could be 1 only. Are you getting this point? Understood? So the OB distance, this OB distance is equals to 1 unit, but OB distance is not 1 centimeter. Why is that so? Because 1 by under root 5 unit was represented by under root 5 centimeter. That means 1 unit is represented by 1 by under root 5 unit is represented by under root 5 centimeter. That means 1 unit is represented by 5 centimeter. That means this OB distance is equals to 5 centimeter. Are you getting this point? What did I do? Which is the value of OB is equals to x only. So this is the value of x. Or directly let's write it OB only, nothing else. This is your OB. I hope you are understanding. What we are doing is that we need to find OC and OB distance. We know one thing, that at point A, what is being cut? At point A. At point A, x equals to 1 and r equals to 1. That means my normalized impedance is 1 plus j. If I know the normalized impedance, then I can calculate the gamma L value. I got to know that it is 1 by under root 5, which is equals to OA. This is equals to OA only, which is equals to under root 5 centimeter. So this is equals to under root 5 centimeter. So here in the Smith chart, 1 by under root 5 unit is represented by under root 5 centimeter. That means 1 unit is represented by 5 centimeter. Now we are talking about point B. Now at point B, I am not given the value of your x. That means I am not given that reactive part. So I am assuming any reactive part is there, that is x1. But certainly the value of r is 0. That means my mode of gamma L will be certainly 1 unit. That means if I join this point to the origin, that means this OB length will be represented by 1 unit, and 1 unit is equivalent to 5 centimeter. That means OB distance is equals to 5 centimeter. Are you able to understand this point? These kind of good questions will be coming. Okay, this will lie in a very good question. Now if they ask you the OC distance, so at OC distance, which two curves are cutting? At OC, if I ask you what will be the value of ZL dash at point C, what you can see, that is, sir, r equals to 1, this curve is r equals to 1, and this curve is x equals to minus 1. So r equals to 1 and x equals to minus 1. And if you find the value of gamma L, at which point you are finding ZL dash C, so that would be 1 minus j minus 1 upon 1 minus j plus 1. That would be minus j upon, not mode of gamma L, I am directly finding gamma L only. So minus j upon 2 minus j. So what is mode of gamma L here? That is 1 by under root 5 centimeter, 1 by under root 5 unit. Right? So this mode of gamma L is becoming this mode of gamma L and this mode of gamma L, here you are getting 1 by under root 5 unit, both are equal. That means both distance has to be equal as well. This OA has to be equals to OC. Are you getting this point? OA and OC has to be equal. Why is that so? Because at both of the point at A and C, the value of gamma L is same. That means OA has to be equals to OC. So OA is equals to OC is equals to under root 5 centimeter. So this is the third answer. Are you able to understand this point or not? At point C, I got to know that my mode of gamma L is 1 by under root 5 unit. That is the same at point A as well. At point A as well, if my normalized load impedance is 1 plus j, if my normalized load impedance is 1 plus j, or my normalized impedance is 1 minus j, both of them will give me the same mode of gamma L value, that is 1 by under root 5. That means if I join these points from to origin, then that distance has to be equals to same only, OA has to be equals to OC only. There you go, that's it. Okay, so I hope you are understanding. I know this is not that straightforward, but you need to keep your full concentration, then only you will be able to understand, otherwise it will become complex. But I will deal every single concept that is related to Smith chart. So I'm not gonna leave any single point. Okay, all the points we are going to see. Now this is also a good question. These kind of questions are also asked. Now what you need to tell me? You need to tell me the nature of load at all these points, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, whatever that is there. At all these points, you need to tell me the nature of load. Let's talk about point A. Now this will be given in the examination that this is your R equals to 0 circuit. Sorry, this is your R equals to 0 circle. Rest all you need to tell on your own. Which circle will be this? R equals to 1. Which circle will be this? X equals to 1. Which circle will be this? X equals to some 0.5. This I am giving from my own side. It could be anything. Let's just say it is some 0.5. This what this would be? X equals to 0. What this circle would be? X equals to minus 1. What this circle will be? X equals to some minus 2. Right? And this is X equals to 0 only. Okay, done. X equals to 0, R equals to 1. Okay, and what this point will represent? This point will represent X equals to infinity and R equals to infinity. Like if this is X equals to 1, then why did I call it X equals to 0.5? It could be anything. It could be 0.7, but certainly it will be lesser than 1, because as the X size decreases, the radius increases. So this radius is more. Similarly here, if I am calling it X equals to minus 1, then I am calling it X equals to minus 2. Why is that so? Because if radius size is small, then X value has to be large. So this value has to be large. So if this is X equals to minus 1, this is X equals to minus 2. Now you can name all the points very easily. Let's start now. Okay. At point A, what is the value of ZL dash at point A? So which all two curves are cutting? R equals to 0 and X equals to 1. R equals to 0 and X equals to 1. So R is equals to 0 and X is equals to 1. Purely inductive. Purely inductive. Similarly, at point B, where is point B? This is R equals to 0 and X equals to 0.5. R equals to 0 and X equals to 0.5. Purely inductive. At point C. At point C. X equals to 0 at point C. Look, X is equals to 0 and R is also equals to 0. On this complete curve, R is equals to 0, but this is cutting here X equals to 0. So X is also equals to 0, R is also equals to 0. So 0 plus J0, that means short circuit. So this point is short circuit. Point D. So here X is equals to 0. This is X equals to 0. And what about, sorry, not X equals to 0, sorry, R is equals to 0. This is your constant R curve. R is equals to 0, but X equals to minus 1. R is equals to 0, but X equals to minus 1. So that means this is purely capacitive. ZL dash at point E. Which point is E? This is your point E. So R is equals to 0, R is equals to 0 and X equals to minus 2. R is equals to 0 and X equals to minus 2. So purely capacitive again. E, F. So all kind of points we are going to see E, F. So now in F there will be doubt. What some guys will say that sir, this is your X equals to 0 circle, right? And sir, this is your X equals to 0 line. So X equals to 0 line and X equals to 0 circle, both are cutting at this point as well. Someone will say that sir, R equals to 0 and X equals to 0, both are cutting at this point. And what someone will say that sir, X equals to infinity is this circle and R equals to infinity is this circle. Again I am telling 2 points that X equals to 0 and X equals to 0 and R equals to 0, both are cutting at point F. Are you able to agree to this point? And X equals to infinity and R equals to infinity, they are also there. What else can be said? That sir, R equals to 1 and X equals to 1, they are also being made at point F. What else can be said? That sir, X equals to 0.5 and this is some circle which I did not name. This circle can be called as R equals to 0.5. Okay, this circle I forgot to name. This can be called as R equal to 0.5 because 0, 0.5, 1 and smaller it will get. So this can be called as R equals to 0.5. So one can say that sir, at this point X equals to 0.5 and R equals to 0.5. This is your R equals to 0.5 circle, no? This is your R equals to 0.5 circle. So that is also there. But at point F, which two circles are cutting? Look, from 1, 0, this is your 1, 0. From 1, 0, all these are originated. But what is the locus of circle there? Locus of circle is that circle which is having center 1, 0 and radius equals to 0 as well. The locus of the circle at point F is centered at 1, 0 and radius is 0. So here those two circles are cutting. From this point all other circles are originated. At this point all other circles are originated. But if you talk about the locus of two circles cutting here, that is the circle which is having 1, 0 radius, 1, 0 center and 0 radius. Which are those two circles? For x equals to infinity and r equals to infinity. You can see here r equals to infinity, center at 1, 0 and radius is 0. And x equals to infinity, center at 1, 0 and radius is 0. So at this particular point, you are having two circles which are lying on each other. And those circles are made for r equals to infinity and x equals to infinity. So this point F is represented by infinity plus j infinity. That means open circuit. Are you getting this point? So from this point all other circles are being originated, but if you say the locus being cut, that means x equals to infinity and r equals to infinity. So x is equals to infinity and r is also equals to infinity. Yeah, this was short circuit, this is open circuit, or you can say infinity impedance. EFG. What about G? G. So on G, which all two circles are cutting? R equals to 1, right? And x equals to 0. R equals to 1 and x equals to 0. So R is equals to 1 and x is equals to 0. So here ZL dash at point G is equals to 1. What is ZL dash? ZL dash is ZL by Z naught. ZL by Z naught at point G is equals to 1. That means at point G, ZL is equals to Z naught. And what do we call it? Matched load. Right? Matched load. And now if you join this point to origin, if I join this point to origin, then this will be my gamma L. If I join this point to origin, then this will be my gamma L. If I join this point to origin, then this will be my gamma L. If I point G to origin, if I join the point G to origin, what I am saying, if I join the point G to origin, then what will be my mode of gamma L? That will be 0 only, no? Why is that so? Because G is at origin only. You are joining point A to point A. Then what will be the length? 0 length only. So mode of gamma L should be 0 only. And for matched load, what is the mode of gamma L? 0 only. Are you able to connect the points now? Right? If I join this point to origin, then this will be my mode of gamma L. If I join this point to origin, then this will be my mode of gamma L. If I join this point to origin, then this will be my mode of gamma L. If I join G point to the origin, then my mode of gamma L will be 0. And that means it is matched load. And from other thing also we can verify, because this is your R equals to 1 and this is your X equals to 0. R equals to 1, X equals to 0. If you put R equals to 1 here, X equals to 0, then this is what you are getting. Is that clear to you? Okay, well and good. Things are going smooth. So E, F, G we have seen. Now H. So at H I can see R is equals to 1 and X equals to 1. R equals to 1 and X equals to 1. So what kind of load? Complex but inductive. Complex inductive. E, F, G, H, I. So R equals to 0.5 and X equals to -2. R equals to 0.5 and X is equals to -2. Complex but capacitive. ZL dash GHIJ at G. So R equals to 0.5, R is equals to 0.5 and X equals to also 0.5. R equals to 0.5, X is also equals to 0.5. So complex inductive, right? E, F, G, H, I, J, K. K is the last one. No, L is the last one. Where is L? Oh, here is L. So what about K? So X is equals to -1 and R is equals to 1. X equals to -1 and R is equals to 1. So this is your complex but capacitive. Now I need to see JKL. So at L, R equals to 0.5, but X is equals to 0. R equals to 0.5, but X is equals to 0. So this is your purely resistive. Purely resistive. Now from all these things, one conclusion you can make. What is that? That on Smith chart, this upper part will be inductive load. It could be complex inductive or purely inductive, I don't care. You see at point A, B, J, H, A, B, J, H, A, B, J and H, all are inductive, 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 inductive. Some are complex, some are pure. That means the upper part will always be inductive. And why is that so? Because in the upper part x equals to 1, x equals to 0.5, x equals to 0.7, x equals to 2, all these will be there. And r will be a real value there. 0, 1, 2, 0, 1, 0.5, 0.6. So upper part will be always inductive. It could be complex or pure. Complex or pure. Okay. It will be pure inductive when you are on this circle, r equals to 0. And if r is not equals to 0, then it will be complex. And the lower part will be capacitive. You can see these points. K, I, E, D. K, I, E, D. Okay. Let's see this point. K, I, E, D. K. First we will see K, capacitive. K, I, capacitive. E, capacitive. D, capacitive. K, I, E, D, all are capacitive. So this part would be capacitive. It could be complex or pure. Okay. What about this line? On this line, x is equals to 0. R can also be 0. But if you see the point L was, if you see the point L, where is the point L? If you see the point L, it was purely resistive. So on this line, you can get short circuit, you can get open circuit, you can get purely resistive, you can get matched load. So about U line, what I am calling about this U line. So here you can get purely resistive, capacitive, sorry, not capacitive, sorry, purely resistive, open circuit, short circuit or matched load. Okay. So what I am saying is that what I will mark this way I will mark resistive. This point is your short circuit, this point is your open circuit and this point is your matched, which I am not writing. So will it be clear to you? If the Smith chart is given, then where upper part inductive, lower part capacitive, this part resistive, short circuit, open circuit, anything. This point will be short circuit, this point will be open circuit, this will be matched. Is that clear to you? And how will you remember? Sir have asked me to remember few of the circles. Which circles? That sir, r equals to 0, r equals to 1, x equals to 1, x equals to minus 1. That's it. If you remember this circle and you need to remember this point. Which is this point? X equals to infinity and r equals to infinity. Then if you know these points, then most of the problems will be solved. More things we need to see. We need to see way more things there. Okay. So we will solve this problem. Later on, we will see the analysis of a standing wave pattern on Smith chart. So let's solve this problem. The given circle is v square plus u square is equals to 0.5. Find the value of gamma L on point A, B, C, D, E, F, G, H. You do not need to find the mode of gamma L. You need to find the value of gamma L. That means angle also you need to find. So this is your U, this is your V. If I make any x iota y and I say that z is equals to x plus iota y, and now I give a point that is 2, 3. Okay. Then I ask you, what is the value, what is the mode of z at point 2, 3? What you will say? Sir, under root 2 square plus under root 3 square. Or you can say x square plus y square. Under root x square plus y square. What is this circle? This circle is u square plus v square is equals to 0.5. Let me make it more better. Actually, it should be 0.5 square. So what is this circle? This circle is u square plus v square is equals to 0.5 square. That means this radius is 0.5. Forget about all these resistance and reactance, okay? We are not talking about resistance, reactance, anything now. What we are doing is that on this particular circle, we are getting to know that this circle equation is v square plus u square is equals to 0.5. So on this complete circle, the mode of gamma L will be 0.5. Do you agree to my point or not? What this length will represent? Mode of gamma L. Mode of gamma L. What is your gamma L? U plus iota v. What is your gamma L? U plus iota v. And if you calculate mode of gamma L, what that would be? Under root v square plus u square. And what is the value of under root u square plus v square? That is 0.5 only. Under root v square plus u square is 0.5. So this point will be mode of gamma L. Do you agree to this point? Because this is the circle, no? On this circle, this will be the radius, 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 this will be the radius. All these are radius. And on all these points, whether it is A, B, C, D, E, F, G, H, any point, on all these points, mode of gamma L will be 0.5. Because this is your u plus iota v plane. If I had made x plus iota v plane and at point 2,3, if I had asked you the value of z, mode of z, then what you would have done? Under root 2 square plus 3 square. Okay. Similar thing I am doing here. What will be this point? That I don't know. But certainly I know that on this point under root u square plus v square is equals to 0.5. That I know. Because this is the point of a circle. And on this circle under root u square plus v square is equals to 0.5. That thing I know. Right? So mode of gamma L on all the points. Mode of gamma L on all the points, whether it is A, whether it is B, or till it is H. It will be equals to 0.5 only. Now, if your mode of gamma L is same, then what is your standing wave ratio? 1 plus gamma divided by 1 minus gamma. If gamma is same, that means on all the point, the standing wave ratio at point A is equals to standing wave ratio at point B is equals to standing wave ratio at point C is equals to standing wave ratio at point H. So on all these points, the standing wave ratio is constant. What that would be equals to? 1 plus 0.5 divided by 1 minus 0.5. So that would be equals to 3. So on this complete circle, the value of VSWR, what is this known as? VSWR, voltage standing wave ratio or current standing wave ratio. So on this complete circle, the VSWR is constant. So this circle is known as constant VSWR circle. Constant VSWR circle. What we are doing, this is U, this is iota V. We got to know that we will make a circle here. Forget about this constant resistance and reactance circle now. Forget about this concept. Don't forget it, but as of now you forget this concept, okay? Now what did I tell you? That u square plus v square is equals to 0.5 square, that circle I am making. Now on the circle, if I am taking any point, so all those points will follow the equation u square plus v square is equals to 0.5 square, right? That means on all the points, mode of gamma L will be equals to 0.5 only. Now if I need to find the magnitude, if mode of gamma L is 0.5, that means my VSWR, that is 1 plus gamma L divided by 1 minus gamma L, that will be constant. So this circle is known as constant VSWR circle. This is not Smith chart. Smith chart was this. A lot of people call this as Smith chart. This is a Smith chart. No, this is not Smith chart. This is something that I am making. This is my constant VSWR circle. Now this circle I will make on Smith chart and then I will study it. But before that you need to know about this circle. What do you mean by constant VSWR circle? Constant VSWR circle means on UV plane you are making a circle where all the values of gamma is constant. If value of gamma is constant, that means certainly the S value is constant. And certainly if you make any circle on UV plane, then certainly on this plane the value of gamma L will be constant. Why is that so? Because mode of gamma L is equals to under root v u square plus v square. And what will be the equation of u square plus v? What will be the equation of circle? The equation of circle will be u square plus v square is equals to some alpha square. So certainly on this circle, on all point, mode of gamma L will be constant. Now if I need the complete value, that means let's just say I need gamma L at point A. So what I will write? Mode of gamma L point A at point A and then the angle. So mode of gamma L I know already 0.5, and what is the angle? Angle is 45 degree. So e to the power j 45. What about at point B? That would be 0.5 and angle will be 90 degree, right? Oh sorry, this is point A. So at point A angle is 90 degree. Sorry. At point A angle is 90 degree. Really sorry. Point A angle is 90 degree. And at point B, what is the angle? Where is point B? At point B angle is 180 degree, or you can say pi. Angle is always measured from positive u axis. So this will be your angle, that is pi. Positive u axis, okay? So that will be pi. So this can be written as minus 0.5. This can be written as 0.5 g. So you write down all other gamma L values, okay? A, B, C, D, E, F, G, H, I, J, K, all other you write down. I will take a break and then I will restart. Okay, you write down all the values, then you just check it whether you are writing it correct or not. Yeah, so these value we will get, which I have already written down. So why to waste time? This was very simple. All are having the magnitude of 0.5 and the angle I can write down. At C you are having minus pi by 2 angle. At D you are having 0 degree angle. At E you are having 45 degree angle. At F you are having 135 degree angle, which is written as 3 pi by 4. At G you are having minus 3 pi by 4 angle, and at H you are having minus pi by 4 angle, right? So these angles I have already done, and this J pi can be written as minus 1. This J 90 degree can be written as J. Minus J pi by 2 can be written as minus J. And these are pi by 4, 3 pi by 4, minus 3 pi by 4 and minus pi by 4. I hope you would have written it on your own, because you have been following this EM wave from a very longer time. Like if you are following this playlist right from the beginning, then certainly you would be able to write it down. So what we got to know is that on UV plane, if I make any circle, so on that circle, all the points will be having same gamma value, and that circle is known as VSWR, constant VSWR circle. Okay, on UV plane, any circle will be having a lot of points, and at all the points you will be having the value of mode of gamma equals to constant. Also the standing wave ratio will also be constant. Okay, certainly the angle will change, but mode of gamma L will be constant on all these points. So this conclusion we have made. So certainly we will use this conclusion somewhere. That's why I have taken this question. This question will not be asked in your examination, but this conclusion will be helping you somewhere. Now let's solve a general knowledge question. This is a general knowledge problem. This conclusion will also be used somewhere. That's why I am asking it here. So general knowledge question I am asking. What I am asking is that what is the distance d? This distance d you need to tell me in terms of lambda. Try thinking about it. So let's start. Okay. I hope you thought it on your own. Okay, I hope that. So now, do I know this distance? Which distance I am talking about? The distance between a minima and a maxima. Yes. What is that? Lambda by 4. Now this is your maxima, this is your maxima, this is your minima. So from minima to maxima, if you are going, you are taking lambda by 4 distance. You need to work for lambda by 4 to go from minima to maxima. Now this is the midpoint. If this is 5, this is 3, then this is 4. This is the midpoint. So from 3 to 5, you are going for lambda by 4 distance. If you need to go from 3 to 5, you need to work for lambda by 4 distance. If you need to come from 4 to 3, how much distance you need to walk? Lambda by 8, right? So D will be equal to lambda by 8. From midpoint to from midpoint to minima you are coming. That means you are walking lambda by 8 distance. Or you can understand by the example as well. 3, 5 and this is 4. 3 to 5 lambda by 4, then 4 to 3 would be lambda by 8. Right? Now in the next diagram, you tell me the D distance will be greater than lambda by 8 or less than lambda by 8. It would be greater than lambda by 8. Why is that so? Because let's just say this was some 5, this was 3, this was 4. So this would be somewhat greater than 4, 4.5. So from 3 to 5 you are taking lambda by 4. Then 4 to 3 you would take lambda by 8, half of that. Half of lambda by 4 is lambda by 8. So certainly if you are coming from 4.5, that means you will take more. So D has to be greater than lambda by 8, and in the next one D will be less than lambda by 8, right? So this conclusion will also be used somewhere. Okay, very important conclusion. It will also be used somewhere. Okay, so now let's solve this question. So these kind of questions we have already solved in our previous lecture. So why we are solving it again? Because we are going to relate it with the Smith chart and constant VSWR circle. So that's why we are solving it. You can try doing it on your own. What you need to tell, first you need to tell me the reflection coefficient at different length, and then I need to show it on constant VSWR circle. Okay. Then I need to calculate normalized impedance at all these points. Also I need to draw the standing wave pattern. So we will make a very interesting conclusion, and then we will relate it with the Smith chart. So first let's find the reflection coefficient at all these given lengths. So this is the formula of reflection coefficient that we already know, ZL minus Z0 upon ZL plus Z0 e to the power minus 2j beta y. Consider this as a lossless line. The lossless line only is given. Okay. Now what is the value of ZL? 50 plus 50j minus 50. So quickly I can find it out. 50 plus 50j minus 50 upon 50 plus 50j plus 50 e to the power minus 2j beta y. Right. So what you are getting? You are getting this as 50 common if I am taking, so this is what we are getting, right? Now this quantity can be written as its magnitude and angle. So what is its magnitude? Its magnitude is under root 1 by 5. And how do I calculate the angle? The angle will be, this angle will be 90 degree minus tan inverse 1 by 2. And when you calculate it, you get 63.43 degree. Okay, you can calculate this and you get 63.43 degree. 63.43. And certainly there is another thing, that is minus 2 beta y. So in the e to the power j, these many terms are there. So this is your gamma y. Is that fine to you? Gamma y is this. Now at okay, this I can keep here. Now at different points I need to find it out. So first I am finding at y equals to 0. So what you are getting? 1 by under root 5 e to the power j 63.43. Then at y equals to lambda by 8. Because what is y? Y is the distance from load. Y equals to lambda by 8. So at y equals to lambda by 8, if I find 1 by under root 5 e to the power j 63.43 degree minus 2 beta is 4 pi by lambda into lambda by 8. So what this would be? This would be pi by 2. So here directly I am writing pi by 2, or directly I can write that is 90 degree. Right? So what you are going to get? 1 by under root 5 j. Although it is an easy calculation, but I don't trust on myself. I trust more on calculator. So I am going to trust the calculator. This I am getting 26.56. Okay. So this is at lambda by 8. What about at lambda by 4? Y equals to lambda by 4. So whatever that is there at lambda by 8, angle will be subtracted by minus 90 degree. Why is that so? Let's just write down the formula. This is the formula. E to the power j 63.43. Here you are going to write 2 beta y. So what that would be? 4 pi by lambda into pi by 4. So angle will be minus pi. Here what was being subtracted? Here pi by 2 was being subtracted. So here another pi by 2 will be subtracted. So another pi by 2 will be subtracted. So from this minus 90 will be subtracted. So minus 26.56 minus 90. What that would be? It would be minus 116.56. Okay. Are you able to understand this point? Very easy. Why we are doing so, you will certainly understand. Okay. Why we are spending time on all these things, you will certainly understand. This we are doing at lambda by 4. We should keep on making them in boxes. Certainly you can do all these calculations on your own, because till now you should be comfortable with all these things. You will be comfortable with all these things. Now at 3 lambda by 8 they are asking. So if they are asking at 3 lambda by 8, then from this one another 90 degree will be subtracted. Are you getting this point? Because 2 beta y, what will be 2 beta y for 3 lambda by 8? That will be 4 pi by lambda into 3 lambda by 8. So that would be 3 pi by 2. So here pi by 2 was getting subtracted. Here pi is getting subtracted. Now 3 pi by 2 will be subtracted. So from this another 90 degree will be subtracted, right? So magnitude remains as it is, 1 by under root 5. another 90 degree will be subtracted from this value. So what we are gonna get? Minus j 206.56. Now what will happen? At lambda by 2 we are doing. So another 90 degree will be subtracted. Minus 90. What that would be? Minus 296.56. Now you let me know one thing. What this angle is equals to? Minus 290 minus 296.56. This angle is equals to 360 minus 360 degree minus 296.56, right? Basically, from here you are going minus 296.56. That's when you will get this angle, no? 296.56. So from positive x-axis you are going 296.56. So can I do this thing that from positive x-axis in anti-clockwise direction I would have gone 360 minus 296.56, right? So just subtract 360 from it. What you are getting? 63.43. So this can be written as this as well, that it is 1 by under root 5 e to the power j 63.43. And what this is equals to? This is equals to gamma at y equals to 0. Because after lambda by 2 line, the line repeats its properties. We have seen this, no? On transmission line, once we go by lambda by 2, if there was minima, then after lambda by 2, minima is being repeated. If there was maxima, then after lambda by 2, maxima was repeated. If there was ZL, then after lambda by 2, ZL was there, right? If impedance was ZL and the length of the line is lambda by 2. So what will be the impedance? You will see ZL only. So after every lambda by 2, you will see the repetition of everything. So again here as well, the reflection coefficient is also being repeated at lambda by 2. Now if I draw it on constant VSWR circle, that means where I need to draw it on UV plane. UV plane is your complex gamma plane. So on UV plane, I will draw it. So first point at y equals to 0, from where we are starting, magnitude is 1 by under root 5, 1 by under root 5, always magnitude is 1 by under root 5 only. But what is the first angle? 63.43. So angle would be roughly around like this, 63.43, and this magnitude I am calling as 1 by under root 5. So this let's call 63.43. So this was your at y equals to 0. And this magnitude is 1 by under root 5. Okay, this magnitude is 1 by under root 5. Now what is the next angle? Next angle is minus 26.56. So minus 26.56 would be somewhat like this, right? This is at y equals to lambda by 8. Then angle is minus 116.56. So that would be somewhat like this. And next is minus 206.56. So that would be greater than 180. That means that would be somewhere here. And then the again same angle. Okay, so these we calculated at 0, lambda by 8, lambda by 4, 3 lambda by 8, and then again lambda by 2. But in between as well, there will be more lengths, no? In between as well, like between 0 and lambda by 8, there will be some other length, lambda by 16. So in between those curves will come like this. Are you getting to know this thing that once you are moving from 0 to lambda by 8, then you are reaching here, then lambda by 4, then 3 lambda by 8, and then again lambda by 2. Then in this manner you are going. So again it is making a circle only. And what kind of circle is that? This is constant VSWR circle, because all the points lambda by 8, 3 lambda by 8, lambda by 2, 0, lambda by 2, all are having the same value of gamma, that is 1 by under root 5. Mode of gamma is 1 by under root 5 only. The angle is being changed. We started with y equals to 0, then we moved to lambda by 8. In between there could be other points as well. You would find out that when we take other points, you would find out that they are coming somewhere in between only. Then from lambda by 8 to lambda by 4, so you are getting a circle. Okay, so if we make a clearer diagram, what you get to know is that we are getting nothing but a circle only. Now in this circle, if I need to show the points, then this would have been your y equals to 0, then this would have been your y equals to lambda by 8, then this would have been your y equals to lambda by 4, and this would have been your y equals to 3 lambda by 8, and then this would have been again your y equals to lambda. So this was your y equals to 0 and lambda by 2. This was your y equals to lambda by 4. This was your y equals to, not lambda by 4, sorry, this was y equals to lambda by 8. And this was your y equals to lambda by 4, and this was your y equals to 3 lambda by 8. If you ask me what is the difference between these two, what is this angle? Can you let me know? What is this angle? This angle is 90 degree. Why is that so? Because between the angle y equals to 0 and y equals to lambda by 8, what was the difference? 90 degree difference was there. Then again 90 degree. Then again 90 degree. So this angle is 90 degree. This angle is 90 degree. This angle is 90 degree. Then again 90 degree difference. So again you are reaching here. And which kind of circle is that? This is your constant VSWR circle. Circle where mode of gamma is equals to 1 by under root 5. Now what is the conclusion you can make from here? You started y equals to 0 here, and then once you are moving towards the generator, that means your y was getting increased. Y equals to 0, y equals to lambda by 8, y equals to lambda by 4, y equals to 3 lambda by 8, y equals to lambda by 2. That means you are moving towards a generator. If you are moving towards generator, that means on constant VSWR circle, you are moving clockwise. Is that clear to you? When we are increasing the value of y is getting increased, that means you are moving from load to source. Moving from load to source. If I am moving from load to source, what is that equivalent to? That is equivalent to moving clockwise on constant VSWR circle. Moving clockwise on constant VSWR circle. Will you be able to remember it? Okay. So this we need to keep in mind. If I move clockwise on VSWR circle, that means I am moving towards the source, from load to source. This example you can keep in mind. Or how you will remember that, sir, at y equals to 0, I will be having a certain angle. At y equals to 0, I will be having a certain angle of gamma. Okay. Now, if I increase the length, then e to the power minus 2j beta y, this guy will be getting increased. That means my angle will be subtracted. Angle will be going towards negative. This is how you will be remembering. What you will be remembering that, sir, at y equals to 0, my gamma L would be ZL minus Z0 upon ZL plus Z0. So it would be having a certain angle. That angle is theta. Now, if I increase the length y, that means if I move towards the source, then y value will increase. If y value is increased, then this angle is increased, but in negative direction. This angle is increased in negative direction. That means more angle will be subtracted. So now my angle will keep on becoming negative. So if this was the condition, then more negative, it will keep on becoming. That means I am moving clockwise. So this is how you can keep in mind. And this was the example that was given to prove this thing. A very important point. Okay, very important point. And now another thing. If you are moving 360 degree on constant VSWR circle, that means how much you have worked on the transmission line. If you are moving 360 degree on constant VSWR circle, that means how much you have worked on transmission line, lambda by 2, right? Because after lambda by 2, things are being repeated. That means 360 degree movement on constant VSWR circle is equals to lambda by 2 length movement lambda by length to movement on transmission line. Another important point, because after lambda by 2 you can see that your reflection coefficient is being repeated. Is that clear to you? A very important point. Okay, so let's remove these 90 degree angles, which was pretty obvious. Let's remove these 90 degree angles. Just keep this angle here. At y equals to 0, how much angle was there initially? 63.43 degree. We are just keeping this angle, 63.43 degree. And this magnitude was your 1 by under root 5, which we are not showing, but you should know that this magnitude is 1 by under root 5 only. So in this initial angle was 63.43 degree. Is that okay for you? Now what else we need to find? We need to calculate normalized impedance at all the points. So at y equals to 0, what is your impedance? What do you think? Z at y equals to 0. That is your ZL only. Because at y equals to 0, what is the impedance? ZL only, 50 plus 50J. 50 plus 50J. But let's find normalized impedance. Okay, let's find normalized impedance. Normalized impedance at y equals to 0. What that would be? Divided by 50 I need to do. So 1 plus J I will get. Now what I am finding? Impedance at y equals to, what you need to find? At lambda by 8. So what that would be? Z naught into ZL plus JZ naught upon Z naught plus JZL. So Z naught is 50, ZL is 50 plus 50J, then J 50 divided by 50 plus 50J minus 50 it would be, because JZL would be 50J minus 50. So from here if you solve it, 50 get cancelled, here you are getting 50 plus 100J, right? And if you need to calculate normalized, again here also you will get very interesting thing. Okay, so if you need to calculate normalized, that means you need to get what you are getting, 1 plus 2J, 1 plus 2J at lambda by 8 distance, at lambda by 8 we are getting 1 plus 2J. Is this calculation correct? Let me see it. Yeah, this is not correct. And how did I get to know it that this will be incorrect? That I will tell you. Okay, just as I saw that at y equals to lambda by 8 my impedance was inductive. What did I write? 1 plus 2J. So it felt like that this impedance is, no, it did not feel like that. Certainly it tells that it is inductive, but it cannot be inductive. Why is that so? Because you can see that on Smith chart this point will come somewhere here, and that means this load has to be capacitive. So that was the thing. So this thing only I need to prove. That's why I am doing all these calculations. So slowly the things will build up. Okay, I am not gonna write down all the statements, because a lot of places I have seen that just statements are written and people will just mug up the statement, but you need to understand the meaning of all these statements. So that is the more important task rather than just remembering the statements. Okay, so now what we are getting, minus 50J plus 100. So if I calculate normalized, then I need to divide it by, 50 at lambda by 4. Not normalized, I am calculating the real one. So that would be Z naught square by ZL, right? And if I calculate the normalized one, so what I will be getting, that would be Z naught square by ZL divided by Z naught. So what will be my answer? Z naught by ZL. What is your Z naught? 50. What is your ZL? 50 plus 50J. What you are getting? 1 upon 1 plus J. Or that would be 1 minus J divided by 2. This is also capacitive, right? So at lambda by 4 you are getting this thing. So let's make them in boxes, because these results will be used later on. Here this is used, this is used, and at lambda by 4 y equals to lambda by 4 you are getting 1 by 2 minus J by 2, 3 lambda by 8. So at 3 lambda by 8 the formula becomes Z naught into ZL minus JZL, minus JZ naught upon Z naught minus JZL. Why this become minus? Because here what do we write? Plus J Z naught tan beta L. Now beta is 2 pi by lambda and L is 3 pi by 3 lambda by 4, 3 lambda by 8. So this and this goes, then what is left? 3 pi by 4, and 3 pi, tan 3 pi by 4 is equals to minus 1. So that's why minus is there. Okay, so it becomes minus. And if I need to calculate normalized, that means I need to divide by Z naught. So this Z naught will be cancelled. So directly I am calculating normalized one. So Z naught is gone. So normalized, this was the formula. If I am calculating normalized, that means I need to divide by Z naught. So Z naught is getting cancelled. What is ZL? 50 plus 50J minus J 50 divided by, what is Z naught? 50 minus J 50 plus 50J. Okay, so this would be minus and then 1. This would become plus. This would be minus J50 and then minus J50 plus 50. This would become minus J50 plus 50, because here J into 50 plus 50J was there. So J50 minus 50, and then another minus sign is there. So minus J50 plus 50. So what we are getting, 50 divided by 100 minus J50, that is equals to 1 divided by 2 minus J. So if I do 2 plus J and 2 plus J, so what you are getting, 2 plus J divided by 5. Yeah. Okay. It may feel like a time pass for you, but very important results will be there. That's why we are doing all these calculations. Okay. But these calculations will be used. And now at lambda by 2, what will happen? You already know. At lambda by 2, if I calculate, that will be same as at y equals to 0. That would be 1 plus j. Now, if you show them on Smith chart, what you will get to know? Just talking about Smith chart, then this is your, if this is your Smith chart, JV and U. So this 3 lambda by 8, this will come somewhere here. Why is that so? Look, you do not know whether it will come here or here. I am not sure, but certainly I can tell that it will be on the upper side because this load is inductive, complex inductive. What about this one? This will also come on upper side. Now, what about this one? This will come on downward side. And what about this one? This will also come on downward side. And what about this one? This will come on upper side only. So we will relate this constant VSWR circle with Smith chart. We will make this constant VSWR circle on Smith chart. So there we will relate all these things. Okay. So at that time I will be using all these references. So that's why we are doing it all. We are doing it all. Now what we need to do? We need to make a standing wave pattern. So for standing wave pattern, what we write? We write Vy, which is V0 plus e to the power gamma y plus gamma L V0 plus e to the power minus gamma y. So from here V0 plus e to the power gamma y you take common, 1 plus, what is the value of gamma L here? Gamma L is 1 by under root 5 e to the power j 63.43. 1 by under root 5 e to the power j 63.43. And here minus 2 gamma y will be there. Gamma will be replaced with j beta, right? Here minus 2 gamma y will be there. So here I can write minus 2 beta y, right? Now if I need to take maxima and minima, so where will be my maxima? So for maxima, 63.43 minus 2 beta y is equals to, for first what I need to take? I need to take my maxima. So it should be equals to 2n pi. It should be equals to 2n pi. So 63.43 minus 2n pi is equals to 4 pi by lambda into y. N equals to 0 works? Yes. If I put n equals to 0, then this angle will be positive only. So n equals to 0 is working. So y is equals to 63.43 into lambda divided by 4 pi, which is 180. So what we are getting? 63.43 divide, all these we have already studied, that's why we are doing it fastly. So 0.088 lambda, 0.088 lambda, this is what we are getting, 0.088 lambda. So this is your first location of maxima. Later on, how much will come? Later on, what will happen is that 0.5 lambda will be added, 0.5 will be added, so it will become 0.588, more maxima location you can tell. And what about the minima? So certainly you can see that if I subtract 0.25 lambda, that will be negative, so that is not accepted. So I need to add 2.5 lambda. So 0.88, sorry, 0.088 plus 0.25. So that would be 0.338 lambda. That will be the first minima, then more minimas would come. So if I draw the standing wave pattern, then first maxima is occurring, and certainly maxima should be there. Why is that so? Because this is a complex inductive load. And what about the maxima and maximum and minimum value? So, so if you see maximum value and minimum value, so you can directly see that it would be V0 plus into 1 plus 1 by under root 5, and the minimum value will be this one. Okay. So now I need to draw standing wave pattern. So certainly there will be a maximum value, there will be a minimum value, and there will be maximum, minimum, and there will be the midpoint. Now you just let me know from where it will start, from upper side, from downward, from upper side, from the middle, or from here. If it was from middle, that means lambda by 8 distance would be there. If it is starting from upward, that means more than lambda by 8 distance you need. And if it is starting from here, that means less than lambda by distance you need. So how much distance you need? Sorry, first maxima is occurring, no? First maxima is occurring, okay, sorry. So if it is starting from here, that means you need lambda by 8 distance to go to the maxima. If it is starting from here, that means you need more than lambda by 8 distance to go to the maxima. And if it is starting from here, that means you need less than lambda by 8 distance to go to maxima. What is lambda by 8? What is the value of 1 by 8? 0.125. 0.125. So I need less than lambda by 8 distance. My first maxima is occurring at less than lambda by 8 distance. That means I need to walk less than lambda by 8 distance to reach to my maxima. So I need to start from here. Because just as I have walked only this much distance, just as I have walked this much distance, I have reached my maxima. If I was starting from here, that means I need to walk more distance. I need to walk more than lambda by 8. Are you getting this point? So this point we have also already seen. So that was the reason why I solved these questions. Which questions? These questions. That here you are getting minima first. Here you are getting minima first. So total lambda by 8 distance is required. Why lambda by 8 distance is required? Because this is the midpoint. So from here to here, lambda by 4 you were taking, so this was the midpoint. Now this d will be greater than lambda by 8 and this d will be less than lambda by 8. But now in case of maxima, it will be opposite, right? Because I need to go to the maximum value. So if I am near to the maximum value, that means I would require lesser distance. If I am far away from the maximum value, that means I would require more distance. So I am near to the maximum value. So this distance is 0.388 lambda, which is not our matter of concern. But this is how the pattern will go. Okay. So this maxima you are getting at 0.338 lambda, and no, sorry, this is not 0.338 lambda. This point is where you are getting your first maxima, that is 0.088 lambda. 0.88 lambda. What about this point? This point is 0.338 lambda. What about this point? This point is 0.588 lambda. So this is your y, and this is the Vs. And maximum minimum point is there. Certainly VSWR is finite as well. Okay. Now why did we see all these points? This point is 0.088 lambda. Now let's go to this constant VSWR circle again. So this was your y equals to 0 point. Okay. Now how much will be this distance? Look, how much was this distance? This distance was lambda by 8. When you went from here to here, this distance was lambda by 8. Now I am asking how much will be this distance? What I am saying is that 360 degree is equals to lambda by 2, right? So what will be 63.43 degree? So 63.43 degree will be lambda by 2 divided by 360 into 63.43. What that would be? 63.43 divided by 2 divided by 360, that is 0.088 lambda. So from here, if you work for 0.88 lambda, then you reach at this point. Are you getting this point? What did I say? That I am at y equals to 0. I need to cover the distance. I need to cover this much distance. I need to cover 63.43 degree angle on constant VSWR circle. On this constant VSWR circle, if I am covering at distance of 63.43 degree, then at which point I am reaching? I am reaching here. And what is this point? This is the point of Vmax, or you can say I min. Now if I cover this distance plus more lambda by 4 distance, how much will be this angle? This angle will be 180 degree. how much will be this angle? This much angle will be 180 degree, because complete is 360, so this much angle is 180 degree. Now to cover 360 degree, you need to work for lambda by 2 distance. To cover 180 degree, you need to work for lambda by 4 distance. So this distance plus lambda by 4 distance, 0.088 plus lambda by 4. That means if I am coming from here to here, if I am coming from here to here, that means how much I have worked on transmission line. I have worked on transmission line equals to 0.088 lambda plus lambda by 4. That means I have reached to the minima. This is your voltage minima and current maxima. So always on a constant VSWR circle, this point, the right hand point on real axis in the positive direction. This is the positive direction. No? On real axis in the positive direction, you will always get the point of V maxima and I minima, and in the negative direction, you will always get the point of V minima and I maxima. Now I will explain you another thing. Okay, let's just say my y equals to 0 was here. I am assuming it. What I am assuming that my y equals to 0 was here. Now in which direction I need to walk? In which direction I need to walk if I am walking towards source? On the transmission line, if I am walking towards source, then in which direction I need to walk on constant VSWR circle? Clockwise, right? Because movement from load to source is equals to movement clockwise on constant VSWR circle. So this was my y equals to 0. If I move clockwise, then what I will encounter first? I will encounter minima first. So that means this has to be a capacitive load. And is it a capacitive load? Yes, because in this direction you are always having capacitive load. A very interesting conclusion. If I did not make all these things, if I haven't solved all these things, if I haven't made this constant VSWR circle and all these standing wave pattern, then you wouldn't even understand a single point. Now everything you can visualize. If my y equals to 0 was here, then where I need to walk? I need to walk clockwise only, because walking clockwise means you are walking towards the source. Walking clockwise means you are walking towards the source. So now I will walk towards the source and I will observe my standing wave pattern. How my standing wave pattern will look like? So what I will get to know? That if I move here, so first I will encounter V minima. If I am encountering V minima, what does that mean? First V minima is occurring. And first V minima is occurring, that means this has to be a capacitive load. And is it a capacitive load? Yes, because in Smith chart, downward side you will always get capacitive loads. And here what I am encountering first? In which direction I need to walk? I need to walk clockwise only. Because if I walk clockwise, that means I am moving towards the source. So which I am encountering first? I am encountering first V maxima. So which kind of load is that? This is a inductive load. And on Smith chart, you know that on upper side you will always have inductive load. Now another interesting thing, the point was here. Now you know that I will move clockwise, so I am moving towards the source, and if I move clockwise and if I have reached here, if I have reached on this point, that means I have reached my V maxima point. So just by looking at the diagram, will you be able to tell me that whether the distance you need to walk for greater than lambda by 8 or less than lambda by 8? What I am saying, I am repeating my question, okay? I know you did not understand the question. What I am saying is that you know that this is your y equals to lambda. In your question, this has been made that this is your y equals to 0. Not y equals to lambda, sorry. This is your y equals to 0. This is your y equals to 0 point. From here, you are starting. Now you know that if I move clockwise, that means I am moving towards source. So if I move clockwise, I am moving towards source. Now first what I am encountering? I am encountering Vmax. That means first I will get Vmax. So now to get this Vmax, how much distance I will be requiring? Greater than lambda by 8 or less than lambda by 8? So if you walk for 90 degree, that means you need to walk for lambda by 8. But how much angle I am walking? I am walking 63.43 degree. So certainly this distance will be less than lambda by 8. And if this distance is lambda by 8, that means it will start above the midpoint. Are you getting this point? So they can make these kind of constant VSWR circle in the examination. They will give the points and then they will ask you how will the standing wave pattern look like. A very good question, and I am highly expecting these kind of questions will come. Till now they do not ask such conceptual questions, but certainly I am expecting. We will see it again and again we will see it. Okay, now I will do the complete analysis using Smith chart only. So there we will again see it. So it will become more clear to you. But I hope you are able to relate the things now. That why we spent so much of time here just in solving these problems. Okay. So we have verified with our previous analysis as well, and now we are going to do this analysis using Smith chart. So what was our load? 50 plus 50G. Okay. What was our Z note? Z note was 50. So normalized impedance is 1 plus J. So can I show the normalized impedance on Smith chart? What is this? Now this is your Smith chart. This is not your constant VSWR circle. So this is my Smith chart. Where will be my ZL dash? This will be my ZL dash. Now if I know my ZL dash, what I used to do? I used to join this point to my origin. If I join this point to the origin, then what do I get? If I join this point to origin, what do I get? This I get the value of gamma L. What is this? This is my mode of gamma L and this is the angle. This angle I am not sure what is that, but I know if I do the calculation, this angle is coming out to be 63.43 degree, right? This angle is coming out to be 63.43 degree. So what did I get is that what I am doing, first there will be a Smith chart. So this is your R circle, this is your X circle. Where they are cutting? Here they are cutting. So this is my ZL dash. X equals to 1 and R equals to 1. Here I can see that X equals to 1 and R equals to 1. So this is my ZL dash. If I join that ZL dash point to the origin, what do I get? I get my gamma L. So this point is my Y equals to 0. This point is my Y equals to 0. Now I know that on the complete transmission line, the value of mode of gamma L will be constant. On the complete transmission line, mode of gamma L will be constant. Mode of gamma L will be constant on the complete transmission line. I am not talking about the angle. Angle will be changing. First it was 63.43, then minus 90, then minus 90. But the magnitude was 1 by under root 5 only. Magnitude is constant. That means u square plus v square is equal to constant. And what is this? This is the equation of circle. Which circle? Constant VSWR circle. So from taking this radius, can I make a circle now? Taking this radius, if I make a circle, then this circle I am getting. Taking this as a radius, if I make a circle, then this circle I am getting, and this circle is your constant VSWR circle. Constant VSWR circle. Are you getting this point or not? What I am doing, there was a Smith chart. On Smith chart, I got to know that this is my ZL dash. If I join the ZL dash to the origin, that means certainly if I join that to the origin, then this is my value of gamma L. And the angle that it is making with the x-axis, that will be the angle of gamma L. So from here I will get that this is my Y equals to 0 point. Now I need to know if I work on the transmission line, then what will be my behavior? If I work on the transmission line, then what will be my behavior? So for that, what we are going to make? We are going to make constant VSWR circle, because I know that on my transmission line, the mode of gamma will be always constant. Here I should not write mode of gamma L. Mode of gamma will be always constant. Mode of gamma Y will always be constant. That mode will be always constant, but the angle will change. And how the angle will change? Angle will change such that I will always move in clockwise direction. So this is my Y equals to 0. If I am moving in clockwise direction, that means I am moving towards the source. So Y value will be getting increased. So this is your Y equals to 0. If I have worked for lambda by 4, if I have worked for lambda by 4, then this will be, if I have worked for lambda by 4, or I can say 90 degree, then this would be your Y equals to lambda by 8. Not lambda by 4, sorry. 90 degree means lambda by 8, sorry. 90 degree means lambda by 8. And 180 degree means lambda by 4. 180 degree means lambda by 4. And then 270 degree means, from this point I am telling, from this point I have worked for 90 degree, then I have reached lambda by 8. If I have worked for 180 degree, then I have reached lambda by 4. If I have worked for 270 degree, that means I have reached at 3 lambda by 8. And then again at lambda by 2. So did you understand how do you draw a constant VSWR circle? So there will be given a Smith chart. You will get to know your ZL dash. You join that point to the origin. That will be your gamma L. Now taking the radius as gamma L, taking the radius as mode of gamma L, you will draw a circle. Now that circle will be your constant VSWR circle. Why is that so? Because on that particular circle, the value of gamma is constant. And what do you mean by constant VSWR circle? That means you are working on the line. And in which direction you are working? In clockwise direction you are working. All these points are clear or not? Clear? Crystal clear? right? And then this point, this particular point will be your always V maxima, and this particular point will always be your V minima. So here I am writing this is your V minima and this is your V maxima. So the complete question could have been solved just using the Smith chart. So that's why I was saying that whenever you study Smith chart, that means your complete transmission line is coming just on a circle. So this is your constant VSWR circle. This is your not your Smith chart. This circle you are drawing on your own. This circle you are drawing on your own using the Smith chart. Is that clear to you? Smith chart will be given. Using that Smith chart, you can draw this constant VSWR circle, and from there you can make the conclusions. What else you can make the conclusion? That sir, this point is, this is your y equals to 0. Now if I need to go to the Vmax condition, so at Vmax condition, if I need to go, that means I need to work for less than lambda by 8 distance, because I need to work for less than 90-degree angle. 90-degree angle is equivalent to lambda by 8, so I need to work for less than 90-degree angle. That means I need to work for less than lambda by 8 distance. Is that clear to you? And this point is in the upper half of the plane. That means this point is inductive. So certainly I am getting first V maxima. If this point was somewhere here, then first I would have got V minima. And always I will move clockwise only. I will not move anti-clockwise. Always I will move clockwise, because I need to go from load to source. Is that clear to you? All these things are clear. So just this conclusion only I have written here. So if I am moving clockwise, that means I am moving towards source. Okay. Now this I am saying that this is my y equals to 0 point. So if I move towards the source, then what this point will be? First I will be encountering Vmax, or you can say I mean, and here I will be encountering V mean and I max. But this I will encounter after lambda by 4 distance from here. So this will be easy to remember. Why it will be easy to remember? That sir, you will get to know that sir, this is my y equals to 0. Once just as you got to know that you are in the upper half of plane, that means you know that it will be your inductive load. Now if it is an inductive load, what do you know? That first always my voltage maxima will occur. If the load is inductive, then you know that voltage maxima will occur first. If voltage maxima is occurring first, what does that mean? That means if you are working clockwise, that means you are going towards source. So first voltage maxima should occur. So this point has to be voltage maxima. Like you might be thinking that sir, in longer run we may have confusion that sir, whether it is V maxima or V minima. Or in the pressure of the examination, we also have the confusion that sir, this is V maxima or V minima. We will keep on thinking it is V maxima or V minima, V maxima or V minima. So how will you think there? That's our upper half. Okay, that means inductive load. Now where I need to work clockwise. So if I am working clockwise, so this point I am reaching. That means this has to be V maxima, because in case of inductive load, first V maxima is occurring. So you will never do the mistake. Is that clear to you? Okay. Can I call this as point of R max and this point as R min? Certainly I can call it. Why is that so? Because V min divided by I max is R min and V max divided by I min is R max. Now here we calculated the impedances, right? We calculated the impedances at y equals to 0, at y equals to lambda by 8, at y equals to lambda by 4. Now I am giving you a task. You need to calculate the impedance at y equals to 0.088 lambda. Okay. You need to calculate the impedance at y equals to 0.088 lambda. What you are going to do? You are going to apply that formula. Which formula? Z0 into ZL plus J Z0 tan beta L. That formula you will apply. And what you will get to know is that this is coming out to be purely resistive. And what will be its value? Its value will be Z0 into VSWR. Okay. You will calculate it and you will find that this value will be Z0 into VSWR. Why is that so? Why it is happening? What do you think? First, let me keep it in a box and then I will tell you. So why it is happening is that, so note this diagram. As per our diagram, this was our y equals to 0, like, right? As per our diagram, and this was angle 63.43. And when I calculated that if I need to work 63.43, that means I need to work for 0.088 lambda. 0.088 is 0.088 lambda. So that means I need to work for 0.088 lambda. So when I work for 0.088 lambda, I have reached till this point. At this point, what we are having? I max and V max and I min. At this point, I am having V max and I mean, Vmax and I mean I am having. At this point, Vmax and I mean. And if I divide both of them, Vmax divided by I mean, what I'm gonna get? I'm gonna get my maximum impedance. Now on this line, what will be the impedance? Resistive, capacitive, inductive or complex? On this line, the impedance has to be resistive only. No one will say that, sir, this will be open circuit node. Arey no, this is not open circuit node. Like in Smith chart, we used to call this as open circuit node. But when we used to call this as open circuit node? When it is passing from 1, 0. Now it is not necessary that constant VSWR circle will pass from 1, 0. This is, what is this? This is your constant VSWR circle. So constant VSWR circle is not necessary passing from 1, 0. It can pass from this point. This is your 1, 0. So no one will say that, sir, this point will be open circuit. Nah, this is not open circuit. This is your constant VSWR circle. This is not Smith chart. So when I am working for 0.088 lambda, I get to know that this is my Vmax and I mean. And if it is on real U axis, that means it has to be resistive. If it has to be resistive, that means it will be equal to R max. So what formula did we studied? It could be equal to Z0 by S or S Z0. But if the point is of maxima, that means R max has to be larger than Z0. So this formula you will be getting. So at this point, your value will be S into Z0. Are you getting this point? Like this is the most deep anyone can go in any examination from Smith chart. And I can write this on paper that this is the most deep anyone can go. And what about this point? This point will be Z0 by S. So on the same calculation, what else you can do is that on the same calculation here, what did you calculate? You calculate at 0.088 lambda. So same Z you can calculate at 0.088 lambda, 0.088 lambda plus lambda by 4. You can calculate there and it will come out to be Z0 by S, because this is the point of your minima. And how you are starting? First your impedance was, here if I see the impedance, first your impedance was inductive, then capacitive. So from inductive to capacitive you have reached. So somewhere in between certainly you would have reached to resistive as well. What I am saying that you started from here, y equals to 0. From inductive to capacitive your impedance was going, then capacitive, then again inductive, and then again inductive, then again capacitive, inductive. In this manner it was going. So somewhere in between you would have cut on this line, and that line will make sure that your impedance is resistive, and that resistive impedance is this one. So they can ask you the maximum value of resistive impedance on Smith chart, and sorry, not on Smith chart, on transmission line. Maximum value of resistive impedance on transmission line. This thing they can ask. So you always need to keep in mind S Z0 or Z0 by S. Okay, so if they are asking maximum, that means S into Z0, and if they are asking minimum, that means Z0 by S. So just as you move along that transmission line, your impedance also changes. If you are at inductive, then how it will change? Inductive, resistive, capacitive, resistive, again capacitive. In this manner it will change. Are you getting this point? All these points are clear? Okay. So let's not make this here, because this was just to make you understand. But this would be your Vmax, this would be your Vmin, Imax, R mean Z0 by S, clockwise movement, constant VSWR circle. All these are crystal clear, right? And this also I can keep in books. So that's it. That's it about your Smith chart. We will solve some problems. Certainly we will solve some problems. So this you need to draw. What you need to draw? You need to draw voltage standing wave pattern with respect to the points that has been shown on Smith chart. So do it on your own. Okay. Pause the video. Do it on your own. For point A. Point A means with respect to this ZL dash. With respect to ZL dash A. If your load was ZL dash A, then what will be your standing wave pattern? If your load was D, then what will be your standing wave pattern? Or if it was B, then what was your standing wave pattern? If it was C, then what was your standing wave pattern? And take care of that lambda by 8, whether it will start from the midpoint or above midpoint or below midpoint. So that is very important. Okay, very, very important. Or it would be D. So what will be your standing wave pattern? So these kind of questions can certainly be coming in your examination in near future. Okay, so draw it. Like what some people would be saying that, sir, this will be inductive load. So they will say that this is how, sir, A and D are inductive load. So that means first voltage maxima will occur, minima will occur. So yeah, this option is correct. But I will frame three options like that. How I will frame? One option will be going like this, other option will be going like this, and the third option will be going right from the midpoint. Yeah, I know that first voltage maxima will occur. There is no doubt about that. First voltage maxima only will occur. But it will start from the above of midpoint, below of midpoint, or right from the midpoint. That is the important thing. No? So all three will not be correct. One of them will be correct. Are you getting this point? So that's why these kind of questions become important. So here you need to think. So if you are at point A, how much distance you are covering? More than lambda by 8. If you are covering more than lambda by 8, that means you need to walk for more distance. So it will start from below of the midpoint, right? And if you are talking about D, then it will start from above the midpoint. And say same goes for C and B. So think about it and make it on your own. I will take a pause and then I will restart. Okay? Yeah. So try doing it on your own. I have given you the enough hint. Forget about the hint. I have given the solution only. Okay? So yeah, make it on your own. Yeah. So let's start solving. All the concept I have already taught. So first let's make it for A, right? For load A, for ZL dash A. So for ZL dash A, what I can comment? For ZL dash A, I can comment that it is an inductive load. Inductive load. First Vmax will occur. Vmax will occur first. Where I will walk? I will walk in clockwise direction. But the distance will be greater than lambda by 8. Why is that so? Because from here, what you are going to do? You are going to join this point to the, you are going to join this point to your origin. Once you have joined this point to the origin, then this is your, what is this? This is your mode of gamma L. Now taking this as a radius, you will draw a circle. You will draw a circle taking this as a radius. This will be your constant VSWR circle. Now from here to here you need to walk. So this point will be your Vmax point. Now how much you need to walk? Certainly I need to walk for more than lambda by 8 distance. Are you able to understand the point? What is the procedure? The procedure is, first you find your ZL dash, you join this point to the origin, then you make a circle making this as a radius. Then in clockwise direction I need to walk from here to here. So first I am encountering my Vmax. Certainly I will encounter my Vmax, but I need to walk for greater than lambda by 8 distance, right? So maxima will be there, my minima will be there, and certainly there will be a midpoint as well. Okay, so I need to work for more than lambda by 8. That means I need to start from lower end. Okay, so the point is that this distance d, this d will be greater than lambda by 8. So this is your Vs, this is your Vmax, this is your Vmin, and this is at y equals to 0. Okay, and this is your y, and certainly I know that this distance is lambda by 4. This distance is lambda by 4. In the diagram it feels like that the d is greater than lambda by 4. Certainly d cannot be greater than lambda by 4. D has to be less than lambda by 4. So I will write that d is certainly less than lambda by 4 and certainly it is greater than lambda by 8, right? So this kind of relation they can ask in the examination. Okay. Now what about point D? So at point D, what do I see? At point D, how will I make the constant VSWR circle? So this is my ZL dash, then I will join this to origin, then I will make a circle. Then if I move in clockwise direction, then I need to work for less than 90 degree. If I need to work for less than 90 degree, if I need to work for less than 90 degree, that means I need to work for less than lambda by 8 distance, right? So this is also inductive load, and first you can see that first voltage maxima will occur, but how much you need to work? You need to work for less than lambda by 8. Okay, so D has to be less than lambda by 8. So here as well, three conditions. Less than lambda by 8 means, that means from here you start and just you got it. Okay, so this distance D, this distance D is less than lambda by 8. This is for this one and this is for this one. So VSWR tuning. Certainly this is your Vmax, this is your Vmin, this is your midpoint. So very less distance you need to cover. Okay. Now what about at point B? So for point B, what you need to do? You need to join these two origin and draw a circle, taking this as radius. So this will be your constant VSWR circle. Now if you walk clockwise, how will you walk clockwise? This is how you will walk clockwise. So if you walk clockwise, first what you will encounter first? You will encounter V minima. And certainly if this is a capacitive load, you will encounter V minima only. So how much you need to walk? This is your y equals to 0. This point is your y equals to 0. So how much you need to walk? You need to walk for less than lambda by 8. Why less than lambda by 8? Directly I can see because this angle is less than 90 degree. So now I need to work for less than lambda by 8. So V minima will occur, but I need to work for less than lambda by 8. Point B. So I need to work for less than lambda by 8. So at point B. At point B, what else I can conclude that it is a capacitive load. V minima will occur first. Clockwise we are going. Distance D will be less than lambda by 8. Right. So don't need to mug it up. No need to mug up anything. Just pure concept, pure understanding, nothing else. Right. If I need you to mug it up, then I would have simply written down the points that just remember these points, but there is no use of that. Yeah, so this will be your BS. Okay. So first distance will be less than lambda by 8, so I need to start from bottom because less distance I need to cover. If I have started from here, then more distance I need to cover. Okay. First minima, then maxima, and then in that manner we will keep on going. Right. So this distance D, this I am talking about D. So this distance D is less than lambda by 8. And what about the point D? So if I discuss the point D, so at point, no, it is C, sorry, the point is C. So if I see the point C, then I will join it to origin, then I will draw the circle. Where I need to walk, I will always walk in clockwise direction. If I am walking in clockwise direction, what I am encountering first? I am encountering V minima first. But how much I need to walk? I need to walk for greater than 90 degree. So how much I needed to walk? Greater than 90 degree. So D will be greater than lambda by 8. So D will be certainly greater than lambda by 8, but certainly it has to be less than lambda by 4. Okay. Certainly a very good question is coming on this particular topic very soon. I am highly expecting a very good question on this particular topic. So I need to work for greater than lambda by 8. So now they are framing questions from scattering parameters. They are framing questions from Smith chart. So certainly these kind of things are coming in your examination in near future. So this is your distance D. Distance D is greater than lambda by 8. Is that clear to you? All these are clear? Absolutely clear. So let's just write down the all important points. So this is just the summary of all the important points. First and second quadrant which shows the inductive load. Gamma real axis, that means U axis, shows the resistive load plus short circuit plus open circuit plus matched condition as well. Right. Third and fourth quadrant, capacitive load. All constant resistance circle and all constant reactance circle, all the circles will pass from 1, 0 because from 1, 0 in this direction circles are originated and in this direction circles are originated. Gamma real axis works, now this is a new point. Okay. So now how will you make your all constant reactance circle? So these were your constant reactance circle. No? These were your constant reactance circle. So from 1, 0 all the circles were being originated, or same thing you could have done downward as well. Right. Now this line is tangent to all the circles, right? This particular line is tangent to all the circles. What do you mean by tangent? From this point it should pass. So these, like this circle can have more tangents, but this tangent is common to all the circles, right? This tangent is not common to all the circles, but certainly this tangent is common to all the circles. So what is this tangent? This tangent is gamma real axis, right? Or you can say U axis. So gamma real axis works as a tangent for all constant reactance circle. Are you getting this point? So gamma real axis works as a tangent to all the constant reactance circle, whether it is for x greater than 1 or less than 1, x greater than 0 or x less than 0. So that is the tangent. Okay. And what about the constant resistance circle? So what was your constant resistance circle? So all the circles are originated from 1, 0 only. So this circle, this circle, this circle, this circle. So all these were your constant resistance circle. All these circles were originated from 1, 0. So what will be the common tangent? This will be the common tangent, right? What will be the common tangent? This will be the common tangent. And what is this? This is your gamma real equals to 1. What is the equation of this line? This line is tangent to all the constant resistance circle. And what is the equation of this line? Gamma real equals to 1. So gamma real equals to 1. Gamma real equals to 1 works as a tangent to all the constant resistance circle. Okay. So what was the tangent of constant reactance circle? This was the tangent. And what was the tangent? Let me show it again. What was the tangent of all the constant reactance circle? So this was the tangent. And what is the tangent of all the constant resistance circle? This is the tangent. And if two tangents are perpendicular, if two common tangents are perpendicular, that means those circles are orthonormal circle, right? Look, this is one of your constant resistance circle and this is one of your constant reactance circle. Both of them are orthonormal to each other because their tangents are normal to each other. So these are known as orthonormal circles. So in Smith chart, constant resistance circle and constant reactance circle makes a family of orthonormal circles. This is one of the most important statement. Not one of the most important. This is one of the, I would say, this is a good statement that reactance circles and resistance circles are orthonormal to each other. Okay, so this question we will see in assignment. There I have put this question. Just I have put a statement and you need to tell me whether this statement is true or not. So that statement I have put. So I hope you got to know, okay, what we are doing, constant reactance and constant resistance. So this will be the tangent, this will be the tangent. So these tangents we have written. No need to mug up. Just if the statement is written, then you will think that, okay, this will be the tangent, this will be the tangent, then you will tell whether the statement is correct or not, okay. If r equals to 0 represents the biggest constant resistance circle and if r value increases, then radius would decrease. This you already know. This will be the biggest circle, then the radius will keep on decreasing. And x equals to 0 represents the biggest constant reactance circle, right? Because x equals to 0, that means this circle. Then x equals to 1, this circle, then in that manner. So if x value is decreasing, then radius will increase, or you can say if x value is increasing, then radius will decrease. So this is your x equals to 1, this is your x equals to 2. So if x value is increasing, then radius is decreasing, right? So this was about Smith chart. Now what about constant VSWR circle? So 360-degree movement is equals to lambda by 2 distance. Clockwise movement means you are going from load to source. Now you can say otherwise as well, no? If I am walking anti-clockwise, that means I am going from source to load, right? But this we never use. This we never use. This we use. We always walk clockwise. From load to source always we go. But if they are asking that anti-clockwise movement on constant VSWR circle shows, so source to load, right? Intersection of positive real gamma axis and constant VSWR circle is the point of Vmax, Imin and Rmax, right? This was your constant VSWR circle. So intersection of constant VSWR circle and gamma real axis. So this was your Vmax, Imin and Rmax, right? And similarly, intersection of constant VSWR circle and negative real gamma axis, this was your Vmin, Imax and Rmin, right? So this statement I have written. The intersection of negative real gamma axis and constant VSWR circle is the point of Vmin, Imax and Rmin, right? So let's just write down the summary. So I will make some other diagram. Not necessary that I will always pick r equals to 0 and r equals to, not necessary that I will always pick the circle of r equals to 1 and x equals to 1. I will pick some other circle now. So now this can also be any of the constant resistance circle, right? This can be any of the constant resistance circle. I am not sure. This would be certainly r less than 1. That I am pretty sure. Sorry, r greater than 1. This would be certainly r greater than 1. It could be r equals to 2. And certainly this circle will pass from 1, 0. What I am saying is that all the constant resistance circle are originated from 1, 0. So there will be infinite circles like this, right? There will be infinite circles like this. So one of the circle I am making. I am not sure what is the value of r, but certainly it will be greater than 1 because this is my r equals to 1 circle. This is my r equals to 1 circle which I remember. So it will be certainly greater than 1. And one of the other circles I can make, not circle I am gonna make, I am gonna just make somewhat like this. So this can also be possible. So this would be some constant reactance circle. So this would be some r equals to r1. This would be some x equals to x1. Certainly x1 will be greater than 1. X1 will also be greater than 1 and r1 will also be greater than 1. Why is that so? Why r1 is greater than 1, that I have already told. Why x is greater than 1? Because x equals to 1 is this circle. Now if the radius has become smaller, that means x1 has to be greater than 1, right? So these 2 points are there. Now if this is your load, what is your load? If this is your load, then can you find the value of gamma? Yes. What you will do? You will join this point to the origin. Then what you are going to do? This is your value of gamma. And this angle, this will be the angle of gamma. And this point will be your y equals to 0 point. This point will be your y equals to 0 point. Now what you are going to do? You are going to make a circle taking this as a radius. This is how you are going to make a circle. You are going to make a circle taking this as a radius. Now if you work, what this circle is known as? This circle is known as constant VSWR circle. Constant VSWR circle. Now if you work clockwise on this circle, that means you are moving towards source, or you can say towards generator. Okay, this will be the point of Vmax and this will be the point of Vmin. And what about this load? This load will be inductive. All these points also we have covered. So this is just the complete summary. So in Smith chart, we map the value of load impedance on complex gamma plane. Using that load impedance, we make the constant VSWR circle and we can comment on our VSWR, we can comment on our standing wave pattern, we can comment on our load as well. So that was the complete summary. I hope you enjoyed this concept. One of the most typical concept, one of the craziest thing you will learn in your engineering, that was the Smith chart, and I hope I have delivered most of the concept here. Certainly I am not saying that I have delivered all the concepts, like stub matching, all these concepts I did not deliver here, because that will be not useful for your GATE examination. Certainly in masters you will learn it, but if you know this much of concept, then every single concept related to Smith chart you can learn. Okay. Now the Smith chart, this constant VSWR circle, we made for lossless line. This was made for lossless line, right? This can be made for lossy line as well. Look, Smith chart will be same for lossless and lossy, because in Smith chart what do we do? In Smith chart we represent our ZL dash on complex gamma plane. We map our ZL dash on complex gamma plane. So value of ZL dash doesn't depend on your medium. ZL dash will be somewhat that is applied by the user. It could be anything. ZL dash could be anything, right? But now constant VSWR circle means you are working on the transmission line. Now if the transmission line is lossy, then impedance values will change, then your gamma value will change. So you will not get a constant VSWR circle there, because if gamma value is changing, so the e to the power minus 2 alpha z, that factor will also come. So that will be not asked in your examination, but still I will try to deal one of the question based on this concept, that if line is lossy, okay, if the line is lossy, then VSWR circle, this will not be constant. Why is that so? Because your value of z will change, your value of gamma will change, because there is a loss, no? So standing wave pattern will also not look like this. Standing wave pattern will also be losing its amplitude. That maximum, then next maximum will be lesser, then next maximum will be more lesser. This I told when I was teaching you the standing wave pattern, that if the line is lossy. But till now, till this date, in any of the examination, never lossy medium has been asked for standing wave pattern or for constant VSWR circle. So whenever we talk about standing wave patterns, we always assume lossless medium only. So what if the medium is lossy? So one question I will try to deal, one problem I will deal. If the question is coming from that particular concept, then that will be useful for you. Otherwise, in nowhere, even in NPTEL, you will not find much lectures on lossy medium. Okay. So whenever we deal whenever we talk about our standing wave pattern, we always assume lossless medium. We never assume lossy medium. So in NPTEL as well, you will not find much lectures there. Certainly in textbook, there is no content given for lossy medium. But still, I will try to deal one problem in the assignment. That will take very much time because that will be a new concept. So if you are having the time, then you can do. Otherwise, 100% I am saying that medium will be coming. That will be lossless only. Is that fine to you? Okay. So yeah, that's the end of our Smith chart. I hope you enjoyed the video. If you enjoyed it, you do comment down. Thank you very much. Yeah, so now continuing our journey on Smith chart. So this video I will add up with the video of Smith chart only. So now this Smith chart video will become roughly around 4 hours of video. So till now what we have seen, like there would be a Smith chart, there would be constant R circle, constant X circle. So this was known as Smith chart. Now with respect to the Smith chart, we got to know that if we are able to locate our ZL dash, let's just say this was some X equals to X1 and this circle was for some R equals to R1, although this circle is for R equals to 1, that we already know. So if we are able to locate ZL dash, then what we used to do, we used to draw a line from the origin to that ZL dash, then what we used to call that this is our Y equals to 0. Now if we walk on the line, that means we will walk clockwise, and on the complete line the reflection coefficient will be constant. The mode of reflection coefficient will be constant, only the angle will change. So what we used to do, we used to draw a circle and we used to call that circle as constant VSWR circle. Why it was constant VSWR circle? Because on the complete transmission line, if you walk, this was your Y equals to 0, this would have been your Y equals to lambda by 4, and then again this would be Y equals to lambda by 2. So we used to call it constant VSWR circle because our mode of gamma was constant. Why mode of gamma was constant? Because for lossless line, gamma Y was gamma L e to the power minus 2j beta Y. So here you can see is that mode of gamma Y is always equals to gamma L only, right? What is gamma L? ZL minus Z naught upon ZL plus Z naught. So mode of gamma Y is equals to mode of gamma L. So here the reflection coefficient is constant. It is neither decaying, neither it is increasing. Just the phase will change. So this we used to call constant VSWR circle. So this we have already studied. Now the Smith chart will be remaining as it is, whether it is lossy line or lossless line. This circle was for lossless line, right? Now the Smith chart will be same. Why is that so? Because in Smith chart, what do we do? In Smith chart, we map ZL dash onto UV plane. And what is UV plane? UV plane is gamma plane. So this is what we do on Smith chart. And now this ZL dash is something that user will apply, right? User will apply, or it will be the input impedance of the next stage. So this doesn't depend on the lossy or lossless medium. Like this will be your transmission line. Now this is your transmission line. This could be lossy or lossless. This ZL dash will not depend on this lossy or lossless transmission line. So this something user applies, and this is what we do on Smith chart. But this VSWR circle we draw from our own side. This VSWR circle we draw from our own side, saying that the mode of gamma is constant everywhere, just the phase will change. Here the phase is theta 1. Later on the phase can become theta 2. So this circle we make from our own side, saying that mode of gamma L is constant over the complete line. But now if the line is lossy, then what will happen to this circle? What do you think? So this will be our gamma Y. What is the formula of our gamma Y? Gamma Y is ZL minus Z naught upon ZL plus Z naught e to the power minus 2 gamma Y, because the line is lossy. So gamma Y can be written as, what is this? This is your reflection coefficient at load, gamma L e to the power minus 2 alpha x e to the power minus 2j beta Y, not x, sorry, Y. How I can write it? Because gamma is equals to alpha plus j beta. Gamma is equals to alpha plus j beta. So if I open it up, what do I get? Gamma L e to the power minus 2 alpha Y e to the power minus 2j beta Y. So here there is this extra term. So as Y increases, what will happen? This term will go down. What is the graph of this term? This is how the graph will go. So as Y increases, at Y equals to 0, you will have gamma L e to the power minus 2j beta Y. But as Y increases, the magnitude will go down. So now the magnitude of reflection coefficient will go down. So you are not going to get constant VSWR circle. So that is the thing which we need to study now. Now this gamma L is ZL minus Z naught upon ZL plus Z naught. So this ZL can be complex, Z naught can also be complex. So if both can be complex, then certainly this gamma L will have some magnitude. Also it can have some angle. The angle we are denoting by j theta e to the power minus 2 alpha Y e to the power minus 2j beta Y. So what I can write here is that mode of gamma e to the power minus 2 alpha Y. So this shows the magnitude. All these are angle. This is also angle. This is also angle. So all these are angle. J theta minus 2 beta Y. Okay. So this is your gamma Y. This is your gamma y. So this is your magnitude now. This is like this complete expression is for lossy. And for lossless, what was the expression? For lossless, what was the expression? Mode of gamma L, mode of gamma L. This alpha was 0, rest all was same. So now the thing is, on transmission line, now on transmission line, on this transmission line, if you move from load to source, if you move from load to source, then what will happen? This is your y equals to 0, this is your y equals to L. If you move from load to source, then angle will be changing as it is, the way it was changing previously. This angle will be changing as it is, the way it was changing. Initially it was theta 1, so initially you were at a inductive load, then slowly you are going towards resistive load, then you are going towards capacitive, then again inductive, in that manner only. Angle will be changing as it is, but now the magnitude will be going down because this is decaying. Are you getting this point? So on lossy transmission line, your magnitude of reflection coefficient will keep on going down. Okay? Is that okay for you? So if I draw the VSWR circle for lossless line, then it would be something like this. Like let's just say this is my ZL dash. If I have located my ZL dash, now on transmission line, I am going towards the source. So where I will walk? I will walk in clockwise direction. So if I am going towards source, then this is the way I will be going. So at 90-degree angle, roughly here, roughly let's just say this is my 90-degree angle. So at 90-degree angle, you will be getting your lambda by 8. At exactly 180-degree angle, you will be getting your lambda by 4. Then at 270-degree angle, you will be getting your 3 lambda by 8. And then again lambda by 2, and in that manner you will keep on going, because here mode of gamma was constant over the complete line, just the phase was changing. Because if y changes, then phase changes. But mode of gamma was constant over the complete transmission line. Is that okay for you? Now, for lossy, what will happen? Let's just say I have located my ZL dash here. So this is my ZL dash. With respect to this ZL dash at y equals to 0, that means at load, let me use different color of pen. So at load I am having, load means y equals to 0. So at load I am having this much of a reflection coefficient. Okay. But now what will happen? Since my reflection coefficient is, if I only talk about the magnitude, if I only talk about the magnitude, so that is whatever that is at load, e to the power minus 2 alpha y. So as the y increases, this value will decrease. At y equals to 0, this value is maximum, that is 1. So as y increases, this value will decrease. So mode of gamma y will keep on decreasing. So now the reflection coefficient will keep on decreasing. So how it will go? Here, now the magnitude of reflection coefficient will decrease. So now how much magnitude you are having? This much magnitude you are having. Previously, this was the magnitude. In this case, what was the scene? This was the magnitude, and on complete transmission line, this was the magnitude. On complete transmission line. On complete transmission line, the same magnitude was there. But here, what is the scene? Now this is the magnitude. After that, complete same magnitude will not be there. Magnitude will be shortened. After that, magnitude will be more shortened. After that, magnitude will be more shortened. After that, magnitude will be more shortened. So in that manner, magnitude will keep on going down. So how I will make my VSWR circle? So this is what I am making VSWR. So this is not circle now. This will not be circle, because circle means it will come back there only. So I will write down it as VSWR chart. Rather than circle, I am writing VSWR chart. Okay. So this is how it will be going. It will keep on decaying. Let me make it again. So as y increases means you need to work in anti-clockwise, you need to work in clockwise direction. So as y increases, this is how it will keep on going down. So magnitude keeps on going down. So let me remove this gamma L, otherwise this will not look good. Magnitude keeps on going down, then again it keeps on going down, it keeps on going like this, it keeps on going like this, then eventually it will fall to 0. Where it will fall to 0, that I don't know. Like, अरे यार ये तो पूरा ही चला गया. So where it will fall to 0, like after reaching which distance the magnitude of reflection coefficient will fall to 0. Actually, magnitude of reflection coefficient will fall to 0 at y equals to infinity, because if you put y equals to infinity, then this will come to 0. So at y equals to infinity, that means if you take infinitely long line, at that time it goes to 0. So in that manner it will keep on going. Now this is your y equals to 0, right? This is your y equals to 0. Can you let me know what will be this? What will be this length? Think about it. This length is, this is your y equals to 0. What will be this length? And what will be this length? This length will be y equals to lambda by 2. Why is that so? Because if you cover lambda by 2 length, that means you are coming back to the same phase. Look what is happening here. Here this phase is not changing. Initially phase was also theta minus 2 beta y. Now also phase is theta minus 2 beta y. As y increases, the phase is keep on going down. As y increases, the phase keeps on becoming negative. So if y is increasing, the phase keeps on becoming negative. Here the phase was positive. Then y was increasing, the phase keeps on becoming negative. Here it became negative, it became negative. More negative means it is going towards positive only. So at lambda by 2, what was happening? The same phase we were getting. Because what is the phase? Phase was 2 beta y. Phase was changing by 2 beta y. And what is 2 beta? 4 pi by lambda. So if you put y equals to 0, at y equals to 0, you get the same phase. At y equals to 0, you get the same phase. And if you put y equals to lambda by 2, and if you put y equals to lambda by 2, if you put y equals to lambda by 2, so what do you get? You get the same phase, that is 2 pi only, because 2 pi is the same phase only. So here the phase will be theta minus 0 at y equals to 0. At y equals to 0, the phase will be theta minus 0, and at y equals to lambda by 2, phase will be theta minus 2 pi, and theta minus 2 pi is equivalent to theta only. So phase will be same at 0 and lambda by 2. So similarly, this is if your 0, if this is your 0, then at y equals to 0, what was the phase? Theta. So at y equals to lambda by 2, what will be the phase? Theta only. So at lambda by 2, the phase will be theta only. Now another lambda we will cover. So what will be this length? This length will also be lambda. So 0, lambda by 2, lambda. So if I cover lambda by 2 distance, that means I am coming back at the same phase. This we have already studied, right? If you start from 0, if you cover lambda by 2, you come back at the same stage. Then again you cover lambda by 2, you come back at the same stage only. Again you cover lambda by 2, you will come back at the same stage only. The only difference is, just as you move clockwise, here the magnitude keeps on decaying. Magnitude of what? Magnitude of reflection coefficient keeps on decaying. That's the thing. So for lossy transmission line, the magnitude of reflection coefficient will keep on decaying, and this is how your VSWR chart will look like. Here VSWR was a circle. Here VSWR was a circle, but here VSWR is not a circle. It is a chart, you can say, and it will keep on decaying. So only in one of the NPTEL lecture, in Sevgaonkar sir's lecture, this has been discussed, or I don't think in any textbook this has been discussed. Okay, but it can come in your examination, because this is something that GATE examination has never asked till this date. So this might be in their cards. So this can come in your examination, this lossy line. So for lossy line, Smith chart is same, but VSWR circle is different. Why it is different? Because magnitude of reflection coefficient will keep on going down, and that will change with respect to y. As we keep on increasing y, the magnitude will keep on decreasing, but the phase will keep on repeating itself. Here also it was theta, at lambda by 2 also it will be theta, at lambda again it will be theta. Is that clear to you? Let's solve some problems. So this is the first one. The problems are larger. Okay, this is the first question, and this is the second question. So this question itself is on 3 pages. So I have picked tougher question because this is our last lecture of transmission line. So in one question only, I am trying to bring a lot of concepts. Okay, so yeah, let's start. A normalized load impedance is mapped at a point A on gamma plane. This is your normalized load impedance. At 0.36 lambda distance from load. At 0.36, should I make the transmission line? I can make the transmission line. So this was your ZL dash E. I have made it as a resistor, but it could be anything. And from diagram you can tell it is resistive. Sorry, it is conductive. Complex, not conductive, yeah, what I am saying. It is inductive. You can say that ZL dash A is inductive load. Which inductive? Complex inductive. So it will have a resistance as well, it will have a inductance as well. Because here you can see that this is on the upper half of the plane. So in upper half of the plane, we always get inductive plus resistive load. Now, just as you walk 0.36 lambda distance from here, if you have walked 0.36 lambda from here, then at this point, this is your impedance. So just as we walk along the line, our impedance also changes, right? We have seen this in an example. Just as we walk along the line, our impedance changes. So once we have reached till point B, our impedance has become ZL dash B, okay, which is mapped as point B on gamma plane. If the magnitude of reflection coefficient at load was 0.825 and the magnitude of reflection coefficient becomes 0.4 at point B, okay, this should be written at point B, it has become 0.4. At point B, it has become 0.4. Then find the magnitude of reflection coefficient at 0.78 lambda distance from the source. not from the source. Again the question is wrong. From load. Okay, and take lambda equals to 1 centimeter. Did you get this question? This is a very straightforward question, very easy question. Nothing complex is there. What they have given? Mode of gamma y they are talking about. What is mode of gamma y? Magnitude of reflection coefficient at load e to the power minus 2 alpha y, right? We have seen here mode of gamma L e to the power minus 2 alpha y. And if you don't remember, then simply write down the formula. What is the formula? ZL minus Z naught upon ZL plus Z naught e to the power minus 2 gamma y, e to the power minus 2 gamma y. And gamma is, what is gamma? Gamma is alpha plus j beta. So this is your gamma L only, e to the power minus 2 alpha y, e to the power minus 2 j beta y. So what is this? This gamma L will also have some phase. So if you need to take the magnitude only, so mode of gamma L you take minus 2 alpha y, rest will be phase. So now what they are talking about? They are only talking about the magnitude. So what they are saying? This is a very straightforward question. In this question, needlessly I made Smith chart. Sorry, it is not Smith chart. This is VSWR chart. So needlessly I made VSWR chart. This is not even useful here. Why is that so? Because what they have given? They have given the magnitude of reflection coefficient at load. That means this is what they have given. Mode of gamma L. If you put y equals to 0, what you get? Mode of gamma L only. What this is equals to? 0.825. 0.825. The magnitude of reflection coefficient at load. Now what they are saying? And the magnitude of reflection coefficient becomes 0.4 at point B. So when you are reaching point B, you are reaching point B when you cover the distance 0.36 lambda. When you cover the distance 0.36 lambda from load, you reach at point B. You reach at point B. So that means if your y is 0.36, if your y is 0.36, that means you have reached till point B. So whatever the initial amplitude was there, then which distance you have covered, you don't have the value of alpha. How much distance you have covered? 0.36 lambda. 0.36 lambda. Then at what point you have reached? You have reached at the point B. And what is the magnitude of reflection coefficient there? That is 0.4. So what I can write? 0.825 e to the power minus 2 alpha 0.36. What is the value of lambda? Lambda is 1 centimeter. So remember, length is in centimeter. So alpha, unit of alpha will be Napier per centimeter. Okay, so this is 1, but always remember it is in centimeter. So 0.4. So from here we can find the value of alpha. So what will be the value of alpha? I need to use calculator. By 0.63, 0.574, 0.574, but remember it is Napier per centimeter. So this is the value of alpha. Now what they are asking? They are asking at 0.78 lambda distance from load. What they are asking? They are asking the magnitude of reflection coefficient at 0.78 lambda from load. 0.78 lambda from load. So initially what is there? 0.825. Then with respect to distance, if you go, it will keep on losing in this manner. So how much distance you need to pick? 0.87 lambda. So 0.825 was there initially. Then e to the power minus 2 into 0.574 into 0.78. Lambda is also in centimeter. This is also in centimeter. So centimeter will get cancelled. So now this is what we need to do. Into 0.78 into 2. Then e to the power into 0.825. So 0.34 we are getting. So this is the answer. 0.34. So they, in this particular question, Smith chart was not even required, just to give you a feel that your gamma is reducing. Initially what was the gamma? 0.825. Then what is the gamma? Then what is the gamma? 0.4. Then what has become gamma? 0.34. So just to give you a feel that your mode of gamma is decreasing, and how you can understand this. So here this was the mode of gamma. Now this is mode of gamma. Now this is mode of gamma. So you can see the line is getting decreased. Now this is mode of gamma, mode of gamma, mode of gamma. This line is getting decreased. This line is becoming smaller. So what this line represent? This line represents the mode of gamma. So it was maximum here, then it keeps on reducing. It has become smaller. Now it has become very less. So this was your mode of gamma which has reduced. Now taking reference of this question only, you need to solve this one. So I will show you the question, but before that I will teach you one cosine rule. So this we study in mathematics. What is cosine rule? So cos theta will be equals to, this is the angle theta. So cos theta here is equals to, this is a triangle, this has a side, this length is C, this length is A, and this length is B. So if you know the side, if you know the length of all the sides of triangle, then, and if you know this angle theta, so cos theta will be equals to, what is there in front of this? B. So forget about B, you write down C square plus A square. Now what is there in front of it? Minus B square divided by 2AC. This is highly useful, okay? As a student you should know it, because this will be used not in just mathematics problem, not in just EMFT problem, this can be used anywhere in your life. So certainly you should know it. If there is a triangle, sides are ABC, if you need to write down this angle was theta, then how will you write down? A square plus C square minus B square divided by 2AC. If this angle was given cos alpha, so what will be cos alpha? If this angle was alpha, so what do you see in front? C. So forget about C, write down A square plus B square, then C square would come divided by 2AB. So this will be your cos alpha. Similarly, you can write down cos beta as well, if I assume this as beta. Okay, so similarly you can write down cos beta as well. Now let me explain you this question. There, this cosine rule will be used for calculation purpose, not for the concept, but calculation purpose this cosine rule will be used. So let me explain you this question. You can try it on your own. Use your complete concept of transmission line, whatever that you have studied, except from power flow, except transient analysis, or you can say time domain analysis. So these two concepts will not be used here, time domain analysis and power flow concept. These two concepts will not be used, rest all the concept will be used here. Is that okay for you? Okay, so let's start. So this is a source, 10 gigahertz source is there, okay, that is applied to a lossy transmission line 1, lossy transmission line 1, and there is a load ZA, and unknown impedance ZA is connected to a lossy transmission line 1, which is mapped at point A on Smith chart. So I will show you the Smith chart. So this load is mapped as point A on Smith chart, okay. This is a lossy transmission line which is having epsilon r equals to 9, right. So can you find out the value of lambda here? Lambda will be Vp by F, and what will be Vp? Vp will be lambda for this lossy transmission line we are finding. What will be Vp? Vp will be C by under root epsilon r into F. I should have explained the question first, but let's find the value of lambda. So under root epsilon r is 3 divided by F is 10 giga. So what I am getting? 1 centimeter. So value of lambda is 1 centimeter. So this is our lambda. So for this lambda is defined. You will solve it on your own only. Now this is mapped as point A on this particular transmission, this particular Smith chart. This is mapped as point A. So there would be some resistance circle, there will be some there will be some resistance circle, there will be some reactance circle. So both are cutting on this particular point A. So this is how the diagram would be there. Like this would have been some resistance circle, this would have been some reactance circle. So both are cutting at point A. So this is your ZL dash, or you can say ZA. Now what you are doing, at 0.36 lambda distance from load, the impedance on the line becomes ZB. So as you walk on the line, the impedance becomes ZB. Is that okay for you? The impedance becomes ZB, which is mapped at point B on Smith chart. This is mapped as point B on Smith chart. Okay. Now talking about the Smith chart, what they have given? They have given a VSWR circle, constant VSWR circle for S equals to infinity. So this circle is made for S equals to infinity. S equals to infinity means, what do you mean by S equals to infinity? That means mode of gamma equals to 1. So mode of gamma is equals to 1 for this particular constant VSWR circle. They have given the OD distance equals to 1 centimeter. That means mode of gamma equals to 1 is denoted by 1 centimeter. Are you able to understand this point? Mode of gamma equals to 1 is denoted by 1 centimeter. They have given the OA distance. They have given the OA distance. And not mode of gamma, I should have written mode of gamma L. And they have given the OA distance. What is OA distance? OA distance is 0.825 centimeter. What do you understand by that? That means for this transmission line, the reflection coefficient at load would have been 0.825. How do you understand this point? Because if this line is 1 centimeter, if this line was 2 centimeter, let's just say if this line was 2 centimeter, then what is the mode of gamma for this one? What is the mode of gamma for this one? Mode of gamma for this one is 1. And if this line is 2 centimeter, that means one reflection coefficient is denoted by 2 centimeter. That means 0.825 will represent 1 by 2 into 0.825. Then your mode of gamma would have been 0.825 divided by 2. 0.825 divided by 2. So it would have been 0.4125. But as of now it is 0.825 only, because they have given the distance to be 1 centimeter. They have given the distance to be 1 centimeter. So for this constant VSWR circle, your mode of gamma L is 1. If mode of gamma L is 1, then what is your OA? OA is 0.825 centimeter. Your BC is 0.32 centimeter, and this is the constant VSWR circle for S equals to 2.5. So what information you can get from here? VSWR circle for S equals to 2.5, and this point C is on this VSWR circle only. What I mean to say is that point C is present on this VSWR circle only. So with the help of this, can you find the value of OC? That is the task. With the help of this information, can you find the value of OC? This information will be used, this information will be used, and this information will be used. With the help of all these information, you can find the value of OC. If you can find the value of OC, BC value is already given. Can you find the value of OB? What OB will represent? OB will represent the mode of gamma at point B. But what else information is given? Now this ZB impedance is connected to a load. This ZB impedance is connected as a load to a lossless transmission line 2, as shown in the figure below that I did not show. So I need to show that. What we are doing is that we are taking another lossless transmission line. This lossless transmission line has nothing to do with the previous lossy transmission line. Okay. Now what we are doing is that we are connecting this load ZB. We are connecting this load ZB as a load to this lossless transmission line. So this is your lossless transmission line 2, and this is your ZB. Now what they are saying, for lossless transmission line 2, it is observed that the first maxima occurs at 0.4375 lambda distance from the load. So if you work for 0.735 lambda distance from load, then your first maxima will occur here. Here your maxima is occurred. First maxima. Okay. Then find the attenuation constant of transmission line 1. Just use all your brain, use everything, draw the Smith chart for this one. Okay. How you can draw the Smith chart for this one? Because you know ZB. If you know ZB, then you can draw the VSWR circle for this one. When you draw the VSWR circle for this one, you will get to know something interesting there. Which angle you will get to know? From there, can you find the value of OB? And if you know the value of OB, if you know the value of OA, that means this question will become exactly as this one. Because if I know the value of OA, that means I know the value of mode of gamma L. And if I know the value of OB, that means I know the mode of gamma L at 0.63 lambda. And from there, I need to find the value of alpha. So did you understand why did I pick this question? Did you understand why did I make this diagram here? And did you understand how did I frame this question? All thing is clear. ZA was connected. Okay. Lambda is given for them. ZA is connected. And for this as well, same lambda is there. Okay. For this as well, same lambda is there. Here also there will be source that will also have the frequency of 10 gigahertz. Okay. So I will pause the video. I will take a break. You try solving this question on your own. Let me show it again. This is the first slide, second and third. Try solving it on your own. I have given enough hint. Now using all your concept, you should be able to solve it. Okay. So let me pause the video, then I will come back. Yeah. So let's start solving this question now. Okay. So let me connect the mic. Yeah. So lambda value we already calculated, that was coming out to be 1 centimeter. And now we need to see this triangle. What we need, if we have the OA value, we have the OA value because OA is 0.825 centimeter. That means what will be the reflection coefficient considering the lossy transmission line. So for lossy transmission line 1, for lossy transmission line 1, reflection coefficient at load, reflection coefficient magnitude at load, reflection coefficient magnitude at load, what is that? That is 0.825. Why is that so? Because this length, OA length is 0.825 centimeter. This length was 1 centimeter. With respect to 1 centimeter, you go to know that my mode of gamma L is 1. That means with respect to 0.825 centimeter, what will be the reflection coefficient? That would be 0.825. Okay. Now, BC length they have given. BC length they have given. They have given the BC length. Can I get the OC length? Why I am getting the OC length? Because I need to find OB. If I can get OB, how I can get OB? If I have OC length, if I have BC length, if I have OB length, also if I have this angle, then these 4 parameters if I am having, then I can get the OB length. Which, sorry, 3 parameters. Which 3 parameters? OC, BC and this angle. So I need to find OC value. BC value is given. What is BC? BC is 0.32 centimeter. BC is not representing anything. This is just a length. BC is just a length. This is not representing anything. What OA is representing? OA is representing the reflection coefficient at load if your load is ZA. That means this is what OC is representing. Magnitude of reflection coefficient at load if my load is ZA. And let's come back here. What OC will represent? OC will represent the magnitude of reflection coefficient only for this circle, for this constant VSWR circle of 2.5. So if your S is 2.5, if your S is 2.5 for the point C, so at point C certainly there will be some impedance. Like on Smith chart there are infinite R circle, there are infinite X circle. So certainly all the points on Smith chart represent some impedance. So at point C there is some impedance. With respect to that impedance, what is your mode of gamma L? If I take any transmission line and I connect ZC impedance, which impedance? ZC impedance. If I take any transmission line, if I connect ZC impedance, then this will represent my mode of gamma L. Are you getting this point or not? Because this C point represent any impedance on transmission line, although that impedance will be resistive only. Here I can see that this impedance will be resistive, right? So if that, why it is resistive? Because it is on real gamma plane. So if I connect that resistance at the load of any transmission line and if I calculate the reflection coefficient here, what that would be? That would be equals to the length of OC. And how I can get the length of OC? Because I know the S value. I know the S value. If I know the S value, that means can I get the value of mode of gamma L? Certainly I can get the value of mode of gamma L. So this is the formula, but mode of gamma L, see this formula also we know. What is that? S minus 1 upon S plus 1. So that would be 2.5 minus 1 upon 2.5 plus 1. So that would be 1.5 divided by 3.5. 0.428. Are you understanding the meaning of this point C? I hope you are understanding. What is the meaning of point C is that what we used to do is, we used to take any constant resistance circle, we used to take any constant reactance circle. Then what we used to do, we used to find this point. Let's just say this point is some C. What really happened here is that this was your constant reactance circle and this was some of your, let's just say this is only your constant resistance circle. So both are meeting at this point. Once it has reached the, both are meeting at this point, now what I will do, I will join this point to the origin, then this will represent my mode of gamma L. And when I join this point as origin and I take this as radius and draw some circle, this is my constant VSWR circle. So this is given as, this circle is 2.5. This is given as, this VSWR is 2.5. With respect to this circle, your VSWR is 2.5. So from there, can you get the value of mode of gamma L? So mode of gamma L is becoming 0.428. So if your mode of gamma L was 1, then length was 1 centimeter. So now if mode of gamma L is 0.428, then what would be the length? Length will be 0.428 centimeter. If you are following right from the beginning, then certainly you would be able to understand this point, what I am doing here. Why this length, and what is this length? This length is equals to OC. So this length is OC. Why this length is equals to 0.428 centimeter? I hope you are able to understand this point. So these kind of short question can be asked from this particular big question. What they will do? They will make two circles. They will show that the sir OD is equals to 1 centimeter. Then you know that with respect to this VSWR is infinity here. With respect to this VSWR, if your OD is 1 centimeter, that means this radius is 1 centimeter. That means for this mode of gamma L is 1. So with respect to one reflection coefficient, your length is 1 centimeter. Now for this VSWR, what is the mode of gamma L? That is 0.428. That means what will be OC length? OC is the radius and OC will represent mode of gamma L only. So 1 centimeter is equivalent to 1. That means 0.48 centimeter, 0.428 centimeter is equivalent to 0.428 reflection coefficient. So my reflection coefficient is coming out to be 0.428. That means OC length is 0.428 centimeter. I think I have explained enough and you should be able to understand this point. OC is 0.428 centimeter now. Is that okay for you? So OC value we have found out and BC value we are already having. This BC value will also be used. So BC value we are already having. Now BC value we have, OC value we have. Now let's find out this theta. This theta we need to find out. What we need to find out? This theta we need to find out. So let me make the diagram once again. What do you think? What is that theta? So if I locate this impedance, if I locate this impedance on Smith chart, this is your U, this is your V. So if this impedance is my ZB, and then if I have located this impedance and then I join this line to the origin, then what I will get? I will get my mode of gamma L. And then if I make a circle, this will represent my reflection. Sorry, this will represent my constant VSWR circle. Now from this point, if I start walking in clockwise direction, if I start walking in clockwise, this is anti-clockwise, sorry. If I start walking in clockwise direction, then what I will encounter first? Look here, what we are doing, we are making a new transmission line and we are connecting this ZB load. We are making a new transmission line, we are connecting this ZB load to this transmission line, and this transmission line is lossless transmission line. So with respect to this lossless transmission line, for lossless transmission line 2, with respect to this lossless transmission line, can I make this Smith chart? Can I make this constant VSWR circle? Yes, because what is my load? This is my load. If I call this distance at Z equals to 0 and this distance as Z equals to L. So if I start, this point will be my Z equals to 0. And if I keep on working on this line, that means I will keep on working on this constant VSWR circle on anti-clockwise, on clockwise direction. So if I keep on working here, then what I will encounter first? V min. What is this point? This point is V min. And what is this point? This point is V max. So first I will encounter V min. If I keep on working more, then what I will encounter? V max. So this I am reaching after covering 0.4375 lambda distance. Are you getting this point? So if I have covered 0.4375 lambda distance, that means I have reached here. That means what this angle will be equivalent to? What this angle would be? 360 degree angle is equals to lambda by 2. That means lambda by 2 is equivalent to 360 degree angle. That means lambda is equivalent to 720 degree angle. If I have worked for 0.4375 lambda, if I have worked for 0.4375 lambda, that means how much angle I have covered? 720 degree into 0.4375. So what I will get? 315 degree. So this particular angle is 315 degree. So what is this angle? 45 degree, minus 45 degree. This angle is minus 45 degree. Are you able to understand this point? What I am doing here? How did I get this angle 45 degree? Did you understand this point or not? What we are doing is that we are taking this ZB impedance, and we are connecting it to a lossless transmission line. So with respect to this lossless transmission line, can I draw a constant VSWR circle? Because this is a lossless transmission line. For lossless transmission line, this will be the VSWR circle. Now on this VSWR circle, if I work in clockwise direction, that means I am moving towards the source. That means I am moving away from load. And when I move 0.4375 lambda distance, that means at that point I have got my first maxima. So that means this much angle if I am working, then I will get my first maxima. And this much angle is 315 degree. This much angle is 315 degree. So you need to work for 315 degree to get your V maxima. They could have mentioned the location of V minima as well. What they would have mentioned? The location of V minima would be 0.4375 minus 0.25. They could have mentioned the location of V minima as well. So you would know this angle. You would know this angle. Do you know what will be this angle? This angle will be 135 degree. So you will get to know that this angle is equivalent to 135 degree. If you know 135 degree, then you would know that this will be minus 45 degree. But they have mentioned Vmax. That means I have covered 0.4375 lambda. That means I have covered 315 degree. So this angle has to be 45 degree. Now let's get back to the triangle. Let's get back to that triangle. So this angle is 45 degree. This point was our O. This point was our B. This point was C. Do I know the OC distance? Do I know the OC distance? Yes. 0.428 centimeter. Do I know the OB distance? No. OB distance I don't know. Do I know the BC distance? BC distance is given, that is 0.32 centimeter. What will be your OB distance? Can I find it out? Certainly I can find out. How I can find out? That cos 45 degree will be equals to, sir, cos 45 degree will be equals to, this you need to drop. You need to write OB square plus 0.428 square minus 0.32 square divided by 2. What is the formula? B square plus C square minus A square divided by 2BC. Yeah. So 2 into OB into 0.428. So you know what is cos 45? 1 by under root 2. You know this value, you know this value, you know this value. Only unknown is OB. When you solve this, you get OB value equals to 0.4 centimeter and 0.2 centimeter. Both are possible. Okay. Both values are possible. When you solve it, you get these two answers. Both possible. 0.4 is also possible. 0.2 is also possible. Now you will think that that's how two values are possible. Certainly two are possible. What is the property of a triangle? What is the property of a triangle? Let's just say this is 0.2 centimeter. This is 0.32 centimeter and this is 0.428 centimeter. So what triangle says? The addition of two sides should be greater than the third side. So 0.428 plus 0.32 is greater than 0.2. 0.2 plus 0.32. 0.52 is greater than 0.428. 0.428 plus 0.2, that is 0.628, is greater than 0.32. So this property is followed. What is the other property? The difference of two sides should be lesser than the third side. So difference of these two sides, 0.12, should be lesser than 0.428. Yes. 0.128. 0.32 minus 0.428 is 0.108, is lesser than 0.2. Yes. And what about these two? Difference of these two, that is 0.428 minus 0.2, that is 0.228, is lesser than 0.32. Yes. So certainly it is a possible triangle. Same goes for 0.4 as well. You replace this with 0.4 and you check both of the property. So again the triangle is possible. So certainly both of the triangles are possible. So certainly there are two possible values of OB. Since the values are taken random here, from my side I have taken the random values. That's why I got two answers. If they frame these kind of question in the examination, there would be only one possible answer. But these are very random values. This question will not be asked in examination. I just wanted to take a big question so that you understand more and more point. So certainly they will give only one answer with respect to OB. Okay, but here two are coming. So if IITs are framing the problem, then they will frame the problem considering all the scenarios. Okay, so now our answer will be two alpha values. Two alpha value are possible. Okay, so now two alpha value are possible. So OB value you are getting 0.4 centimeter. That means what you are understanding from this point, OB value you are getting 0.4 centimeter or 0.2 centimeter. What do you understand by this point? That means your magnitude of reflection coefficient at point B is 0.4 or 0.2. Say yes or no. If my OB distance is 0.4 or 0.2, that means on this lossy transmission line here, what was my magnitude of reflection coefficient? What was the magnitude? OA is 0.825. So here my magnitude of reflection coefficient was 0.825. When I worked for how much distance? When I worked for 0.63 lambda distance. When I worked for 0.63 lambda distance, which point I reached? I reached at point B. So at point B, my magnitude of reflection coefficient has become 0.4 or 0.2. This is what we can understand from this particular analysis. So this was a very good question. Like every single thing regarding your standing wave pattern I have covered here. Can you let me know what was the load at point A, inductive load? What has the load, what kind of load will be this ZB? This ZB will be capacitive load. So these kind of small questions can also be asked. So you see, like more than 10 information are there in this particular question. In this particular question, you are getting more than 10 information. What will be the impedance at point C? It will be resistive, right? So more than 10 information you are getting. And at point C, will you get maxima or minima? Tell me. If I take any transmission line, okay, and whatever the impedance you are getting at C, that I connect here. So at y equals to 0, will you get maxima or minima or nothing? What do you think? Since C is a resistive load, then I am pretty sure that certainly I will be getting maxima or minima. So will I get maxima or minima? Maxima. Why is that so? Because this is the point of R max, right? This is the point of R max. Why this is the point of R max? Because at this side we always get maxima and this side we always get minima. So this is the point of R max. Or how you can understand? Look, this point will be your 1, 0. Do you agree to this point? This point will be 1, 0, right? Because this is a unity circle. So certainly this point will be 1, 0. Now from here, from this 1, 0, circles are originated. R circle are originated in this direction. X circle are originated in this direction. So one R circle will be originated in this direction. That is passing from point C. And certainly some X circle will also be originated. That X circle will be X equals to 0. So when you will get point C, when both of the curves are cutting at point C, that means X circle has to be X equals to 0 and R circle has to be something R equals to. So this R value will be greater than 1 or less than 1 because R equals to 1 circle was this. So this value has to be R greater than 1. Say yes or no. So this circle has to be for R greater than 1. And if this is R greater than 1, that means what will be your impedance? Impedance at point C, if I talk about ZC impedance. So my ZC impedance, this is having X equals to 0, but R is something greater than 1. So that means my normalized impedance at point C is greater than 1. And what is your normalized impedance? Normalized impedance is the normal incidence divided by Z0. So that is greater than 1. So that means my load is certainly greater than Z0. And if it is greater than Z0, certainly you will get Vmax. So this is the other explanation. What could be the first one? That here at this side always you get maxima. So certainly it is ZL greater than Z0. What is the other explanation? Other explanation is that from here, if you get the circle, so this will be X equals to 0 circle, this will be your R equals to R1 circle. Both are cutting at point C. That means yes, this is my load. So now this R circle will be greater than 1. And if this R circle is greater than 1, that means ZL will be greater than Z0. So these small information you can get from this particular question. Anything they can ask. And I will show you a question as well in GATE 2023 examination. This kind of question only was asked there. So that was very that question was very interesting and you could have solved it within seconds if you solve from Smith chart. And if you do the rigorous analysis, then it will take a lot of time and certainly you will get the wrong answer. So I will solve that question in this particular video only using Smith chart. So you will find that pretty good. Okay. So these many information we can get from Smith chart. And I hope every single thing is clicking to you now. Every single thing is fit in your brain. So that's why I spent a lot of time on Smith chart, and certainly a lot of questions are expected in upcoming year from Smith chart concept. Now they are focusing on these concepts, right? So where were we? So OB we have got to know that is 0.4 centimeter and 0.2 centimeter. That means if I make the diagram now, if I make my lossy transmission line 1, this is my lossy transmission line 1, and this was my load impedance ZLA. So here my reflection coefficient was, if I talk about mode of reflection coefficient, was 0.825. But if I cover the distance 0.63 lambda, then I have reached till point B, and here my reflection coefficient has become 0.4 or 0.2. Here reflection coefficient has become 0.4 or 0.2. So you started with 0.825. Let me add a page. So what really happened here is was your gamma L at y equals to 0, mode of gamma L at y equals to 0 was 0.825. Then your mode of gamma L at y equals to 0.63 lambda, where lambda is 1 centimeter only. Lambda is 1 centimeter only. So at 0.63 lambda, how much it has become? It has become 0.4 or 0.2 or 0.2. So what you can write? 0.4 will be equals to, you started with 0.825 and how it will be reducing? E to the power minus 2 alpha y. And what is the value of y? 0.63 lambda. So 0.4 is equals to 0.825 e to the power minus 2 alpha 0.63. Okay. So this is one of the possible answer. The other possible answer could be that reflection coefficient can become 0.2 as well. So 0.825 e to the power minus 2 alpha 0.63. So this could be the other answer. From here as well you will get the value of alpha, from here as well you will get the value of alpha. So let's check that out. 0.4 divided by 0.825 ln divided by 2 divided by 0.63, 0.57, and certainly it will be in centimeter. Why is that so? Because this 0.63 lambda was in centimeter, so this will be in centimeter. And what about this? Let's write down 0.574. One more value we are writing down. So here 0.2 divided by 0.825 ln divided by 2 divided by 0.63. So 1.124. 1.124 Napier per centimeter. So two possible answers are there. So I did not pick the value smartly, but one possible answer only could be there, right? Either this or either this. But here we are getting two values of OB because both of the triangles are possible. But certainly this question will not be coming in the examination. Did you understand the motive of taking this question? I wanted to give you all these points, that talk about point C, talk about point A, talk about point B, right? Talk about OD. If OD is 1 centimeter, then how I am defining OA, how I am defining OC, how I am getting OB, how I am getting that angle. For getting that angle, what did I do? I connected the transmission line to a lossy one, to a lossless one, then 0.4375. So for that, with respect to that, we can draw constant VSWR circle. So constant VSWR circle concept is also used here, right? So you see how many concepts we have used here, right? Now this question will not come in the examination, and you can go onto my channel, you can check. This question was posted in 2022, okay, on my personal channel, only Vanshu Agrawal channel. I posted this question on 2022, and this question was asked in GATE 2023 examination, okay. This was posted in 2022. In that time I was in third year, okay. So in third year, this kind of concept I used to deliver. So it would be a self praise, but yeah, forget about it. So yeah, like the thing is, you will see a lot of educators, like, I don't want to disrespect any educator. All the educators got my respect, but I have seen some educators saying that I have 1 year of experience only. I cannot teach legendary things like that. They are the gods. They talk about all these things, and show me one educator who can teach all these things, who can teach Smith chart in this manner. Look, I don't want to appreciate myself, like this will be simply self praise, but you wouldn't find these kind of concepts in GATE field anywhere, right? They wouldn't even dare to teach all these concepts. And so there is a reason why I dropped that high paying job and came into teaching. So if you are someone who talks needless about me, then just send them these concept, these content. Like no EMFT educator ever told me anything needless, okay. All the EMFT educators are brilliant, whom I know. Like there are Sonu sir, there are Vishal sir, I can take their name. They are very good educators. They are not just educators, they are a great human being as well. Sonu sir is there, Vishal sir is there, other educators are also there. They are great human beings, they are great teachers. But there are some educators who are not even of this field, and when I am teaching some other subject, they cannot even see my growth. Like if I am teaching all these all things requires a lot of effort. Like you would spend hours of dedication you require, then you will make these kind of content, then you will pick these kind of questions, right? So this is just a reply to all those people who just talk shit behind my back. Okay, so you shouldn't be talking all these things. So that's why I just said that this is something that requires effort, and you can put a like for that, or you can send them these things. Okay, yeah, forget about them. So this question was asked in GATE 123 examination, and you can see this question is based on constant VSWR circle only. Okay, and a lot of student also they solve this question using those equations, but I will solve this question without even using any equation. Without even using any equation, we will solve the problem. So you can try it on your own once. I will also take break. I can drink some water. Then we will start solving this question. Okay. Okay, so let's start solving this question. So this was not an easy question. Okay, if you are not able to solve, then also it is fine. When this question came out, a very few people was able to solve this particular question. They took time as well. But if you are not able to solve it, then also it is fine. No need to be demotivated. But certainly try to get some concept from here. Okay, so let's start this one. This was a MSQ. I should have told it before only. So this was an MSQ. So what they are saying now, what they are saying is that uh, a standing wave ratio on 50 ohm lossless transmission line terminated with an unknown load ZL is found to be 2. So standing wave ratio on this transmission line is 2. Okay, the distance between successive voltage minima and successive voltage minima is 30 centimeter. That means lambda by 2 is 30 centimeter. That means lambda is 60 centimeter. What they are saying, the first minima is located at 10 centimeter away from load. So that means minima location they have given. First minima, that is 10 centimeter. And how it can be replaced with lambda by 6, right? Lambda by 6 will be 10 centimeter. Because lambda is 60, so 60 by 6, lambda by 6 will be 10 centimeter. So minima you are getting at lambda by 6. So where can be your first maxima? Maxima can be at plus minus lambda by 4. So if you do minus lambda by 4, you will get to know that minus lambda by 4 cannot be possible because that will come negative. So at 10 centimeter you are getting first minima. That means first minima is occurred. What I mean to say is that at lambda by 6 I am getting my minima. So for finding first maxima, what do we do? Plus minus lambda by 4. So it could be lambda by 4 before or lambda by 4 ahead. So if I go lambda by 4 before, then what I need to do? Lambda by 6 minus lambda by 4. What I will see here is that this value is some negative value. That would be 3 and 6, 4 and 6 minus 2. So that value will be minus lambda by 12, which is not possible. Negative value is not possible. So it has to be, maxima will be occurring at lambda by 6 plus lambda by 4. That means first your voltage minima is occurring, then maxima is occurring. So its standing wave pattern would be something like this, that first there is minima, then there is maxima. So first there is minima, then there is maxima. Minima and maxima. Okay, and this distance is lambda by 6. So you let me know, lambda by 6 is greater than lambda by 8 or less than lambda by 8. Certainly it is lambda by 8. So if I say this is my maxima, this is my minima, so where will be your midpoint? Your midpoint will be below this, right? It cannot be above this. If it is above this, that means distance will be less than lambda by 8. But you need to cover more than lambda by 8 distance, so it has to be below this. So these concepts we have already seen, right? You have spent a lot of time on standing wave pattern. So if you are someone who needs to study standing wave pattern in a good manner, then you should watch the standing wave pattern video as well. Okay. Now the thing is, at lambda by 6 you are getting your first minima, voltage minima. So this is the VS diagram we have drawn. So which kind of load is that? It is a capacitive load. So if it is a capacitive load, can I show it on Smith chart? Yes. Now the capacitive load could be anywhere, here, anywhere it could be there. So where it would be? It would be in fourth quadrant or it would be in third quadrant. What do you think? The ZL value, this ZL value will be in fourth quadrant or third quadrant. Think about it. What they are saying, you are getting your voltage minima at lambda by 6 distance. At lambda by 6 distance. That means you need to cover lambda by 6 distance to get your minima. That means where will be your minima? Here will be your minima. Your load ZL can be either here or here. You let me know one thing. If it is here, then this much distance you need to cover. Because I will start walking in clockwise direction. So if my load is here, that means I need to cover this much distance, and this distance is less than lambda by 8, but I need to cover more than lambda by 8 distance. That means my load has to be here, right? So I will make it a bit below. So my ZL has to be somewhere here. Are you able to understand this point? First you are getting voltage minima, that means it is capacitive load. Now where it will be, in third quadrant or fourth quadrant? Since your distance is greater than lambda by 8, that means you need to cover more than 90 degree. Lambda by 8 means 90 degree, right? Because lambda by 2 is 360, so lambda by 8 is 90 degree. So you need to cover more than 90 degree distance to reach to your minima. This will be my minima. So I need to cover more than 90 degree distance. So this much angle is 90 degrees, so I need to cover more than 90 degree distance. So that means I have to be somewhere here, right? Now when I reach at this point, what will be my resistance here? This point will be resistive, right? This point will be resistive. So what will be my resistance here? Here you are getting V minima and I maxima. That means you are getting R min here. What will be the value of R min? That would be Z0 by S. So 25 ohm. Now you will keep on working. You walk another lambda by 2 distance. You walk, another lambda by 4 distance. From here you walk another lambda by 4 distance, where you will reach to maxima point. And here what you will get? R max. And what will be R max? Z0 into X, that will be 100 ohm. So at this point you are getting R max, and at this point you are getting R min. That is equals to 25 ohm. Is that okay for you? And then you keep on working. When you cover the complete lambda by 2 distance, you have reached here. So this was your y equals to 0 and lambda by 2. Right? Now what they are saying, we are replacing this ZL with some RM resistance. So how we are replacing? What we are doing is that we are just removing this ZL, then we are connecting another transmission line of length L, the same material we are using, and then we are connecting RM resistance. So what could be the value of LM and RM? This is what they are asking. So two possible RM they have given is 25 and 100. We will see the option. We see that 25 and 100 ohm are the RM they have connected. That means you need to work from here or from here. What do they mean to say is that? Let me explain it. What they mean to say is that you have a transmission line, and if it is connected with RM resistance, if the load is RM resistance, then how much you need to work? So that your impedance here becomes ZL. This is what they are saying. You see here, this is your complete transmission line. This is a complete transmission line only. If here from RM, if I work for LM length, then here I will get my resistance equals to ZL. This is what they have done. From here to here we can go. In the language they have written from here to here. But can I go from here to here? Certainly I can go from here to here. How I can go? That on a complete transmission line, if I work for LM distance, then I will get my load impedance equals to ZL. And what are the possible values of RM? 125. That means from 25, if I work for this much distance, then I will reach ZL point. Where I will reach ZL. So if my impedance is 25 ohm, then I need to work for this much distance. And how much is this distance? Can anyone let me know? Certainly anyone can let me know. I will again draw this diagram here. Okay. Let me draw this diagram again in a clearer manner. So that will be a complete circle. So better I should have drawn a circle only. So this is a complete circle. Here at this point you are having your ZL. Here you get R minimum, here you get R maximum. So this is my R maximum, which is 100 ohm, and this is my R minimum, which is 25 ohm. Okay, and I need to work in this direction. Like this I need to work. So this much length was lambda by 6. this much length was lambda by 6, right? And this lambda by 6 was equivalent to 10 centimeter. This lambda by 6 was equivalent to 10 centimeter. This was equivalent to 10 centimeter. So what do you think, how much will be this length? This lower length is equals to lambda by 4, right? This complete length is equals to lambda by 2. This complete circle is equals to lambda by 2. This length is lambda by 6. So how much will be this length? This length will be lambda by 6 minus lambda by 4. Lambda by 6 minus, lambda by 4 minus lambda by 6. Because complete length is lambda by 4. So lambda by 4 minus lambda by 6. That would be 12, 3, 2. Lambda by 12. So what is lambda by 12? 5 centimeter. So this much length is 5 centimeter. And what will be this complete length then? This complete length. This complete length I am talking about. This complete length will be 15 centimeter. So if I connect my RM to be 25 ohm, then I need to cover 15 centimeter plus 5 centimeter to reach to ZL. Is that okay for you? If my RM is 25 ohm, then cover 15 centimeter plus 5 centimeter, that is equals to 20 centimeter to reach ZL. That means if RM is 25 ohm, then LM is 20 centimeter. There you go. Without even applying a single equation, we solved this question. Otherwise, you can see the solution everywhere. You will find complex derivation they are doing and making this problem complex. But just they wanted you to solve this problem using VSWR circle. So this is the first case. Other case could be, I could have taken my RM as 100 ohm. So if your RM is 100 ohm, then how much distance you need to cover? Then take 5 centimeter distance and reach ZL. That means your LM will be 5 centimeter. There you go. That's it. So this was the question. So whenever you see any question based on standing wave pattern, so what thing first come to your mind? That I will make my Smith chart, and before Smith chart would come into in your mind. Along with that, VSWR circle will also come into your mind. That I will solve this question using VSWR circle, and believe me, 100% it will be solved using VSWR circle. What else they could have asked? They could have asked this angle as well. Which angle they would have asked? How they would have asked is that here my reflection coefficient is gamma L. So magnitude, forget about the magnitude, but tell me the angle. What will be the angle? Here the reflection coefficient has the magnitude of mode of gamma L, but what will be the angle? So can you tell me the angle? What will be this theta angle? So what will be this theta angle? This theta angle is with respect to lambda by 12 distance, right? This theta angle is with respect to lambda by 12 distance. So if lambda by 2 distance is there, that means 360 degree angle. So if lambda by 12 distance is there, that means 360 degree by 6, that means 60 degree angle. So this angle will be 60 degree. So your gamma L could be written as mode of gamma L e to the power minus j60. Why minus j60? Because this angle is actually minus. This angle is negative. So this angle would be minus j60. So with respect to ZL load, your angle of reflection coefficient is minus 60 degree. This they could have also asked. So every single thing you can cover just from VSWR circle. So these kind of depth can be asked in your Smith chart as well. So we have covered every single thing related to Smith chart. I don't think apart from this they will ask anything. If they ask, then it is our bad luck. So roughly around it would be of roughly around 3.5 hour video. So I will upload it completely. Actually, I have already recorded the assignment video. So a very important discussion also I have done. In the end of the assignment video, I will be telling that I will deal about this particular concept later on. Are you getting to know what I am saying? That in the end of the next video, I will be saying that we will see VSWR circle in the next video. But that video is this one only. So I will add this video with Smith chart, and next video will be based on assignment. Okay? You understood what I am saying? In the end of the assignment video, I will be saying that we will study VSWR circle. So here I will be saying that we will study VSWR circle, but that we have already seen. Okay? So this we have already seen. So this video I will be adding up with Smith chart, and assignment video will be separate. So these two, this video and the previous video of Smith chart combined, I will upload. So I will upload roughly around 3.5 hour video. So that will be helpful for M.tech guys as well. Like a lot of M.tech guys will also be studying this concept, I know. Okay, yeah, thank you very much. I hope you enjoyed learning this particular concept from PrepFusion. Thank you very much.